फिर मेरा शेयर भी करवाते हैं। म्यूट कर दिया ना। Well, good morning, all the participants and our esteemed presenter today, Dr. Tirthankar Ghosh. So, friends, we have come to the last day of training, and the time has just flown away. And today we have 3 sessions. The first session, you can say that is a continuation of yesterday's topic. But it will be taken by our speaker, Dr. Tirthankar Ghosh, who is professor and consultant at Sri Sri University, Cuttack, and he'll be talking to you on. He'll be talking to you on quick and effective postural analysis methods, and he'll be talking on OSHA NIOSH lifting equation and injury risk assessment. I'll just brief you about his credentials. So Dr. Tirthankar Ghosh is a professor in physiology and faculty of health and wellness in Sri Sri University, India. And he earned his MSc in physiology, specialized in ergonomics from University of Calcutta, and PhD in physiology, that is in occupational ergonomics from University of Calcutta. He has also earned various international, specifically UK certification as NEBOSH, IOSH, MS and HABC level 2 fire safety. He is also a certified auditor for ISO 9000 2015, 14001 2015 and 4501 2018. He has published conference papers and articles in various journals. He has developed intervention designs and done analysis on the impact of analysis on the impact of modifications on the workers, in which improvement in productivity, health and safety of the workers were significant. In addition to his research, he teaches in various medical colleges of India, China and Nepal for last 16 years. He is a member of Indian Society of Ergonomics, Physiological Society of India, Physical Education Foundation of India, and International Commission on Occupational Health. So we welcome you, Dr. Ghosh, and participants are looking for your very enriching lecture. Thank you very much for accepting our invitation. And over to you, please, Professor Tirthankar Ghosh.
और अनपिन करना लाना
Tirthankar Ghosh. Just a minute.
Thank you, ma'am. Very good morning to all. And I'd like to express my heartiest congratulations to the organizer and want to say thanks to Professor Suman Singh, madam, to invite me to share my knowledge with all of you participants. I also want to express my thanks to the College of Community and Applied Science to organize this program, 5 days training program. This is like one of the very important aspects we are going to discuss today. So I'll just, before that, ma'am, can we just record this?
Yes, it is being recorded on YouTube.
Okay, okay, okay.
Yes, Professor Ghosh.
Yeah, ma'am, screen sharing, I need to get permission for the screen sharing. It's not permitted.
Screen sharing permission दो भाई. Just a minute.
Yes, ma'am.
Yeah, it is done.
Thank you, ma'am. Yeah, it's done.
हेमू वो माउस है क्या बैग में है बैग लाई नहीं है अच्छा ला
Okay, so it's visible.
yeah it's opening
Okay, I think it will take some time.
must be heavy file yeah क्यों क्यों लेट है
Okay,
uh,
I think it's visible now.
yes it is visible but full screen we can't see you know something is cutting at the bottom
No, it's
well
not.
yes it's okay
It's okay.
it
Okay.
may be clear from the next
Yeah,
slide
yeah, yes, ma'am. Okay. Once again, thank you to Professor Suman Singh, ma'am, to give me this opportunity. Uh, Today, I'll be talking about mostly the risk assessment, and part of risk assessment I'll be talking.
वो शोर कर रहा है
There are there are a lot of way we can assess the risk. Exactly, we'll be talking about the weightlifting and how to handle with the different amount of load. And when we are lifting the load, we are not only lifting that, we need to shift that load from one place to another place. We have adapt a lot of awkward postures. We have to change our position. We'll be talking about this, what are the guidelines, how we can assess the various lifting activities.
excuse me Professor Ghosh excuse me Professor Ghosh please unmute yourself once please unmute yourself once
Yeah, ma'am. Thank you. Thank you. Okay, so as for last 4 days, you were discussing about the various ergonomical principles, ergonomical process, methods. I think all of you have that information that how ergonomics is helping us to facilitate our activity. I'll not go in detail for this, but I'll just say that yes, ergonomics is having the potential to maintain the health and productivity of any kind of work. And it's basically facilitating the workers to get a proper working environment. The main motto for the ergonomics not to force the workers to any kind of work. The ergonomics is basically fitting the job to the workers. So we should not force the workers for any kind of work. The work which is acceptable by an individual, this is a very important part. As I say a lot of time, like ergonomics is very much interdisciplinary subject, but it's a very much part of our public health and community health subject. So public health and community health subject nowadays is very familiar to all of us, because when we are in a pandemic situation, we talk about this prevention and this public health aspects. But where we are talking about in general, overall, but ergonomics is a little bit different from the other community and public health. They talk about an individual. So an individual will be definitely different from the general people. So ergonomics do that. Before going to this type of activity, I'll just share some of the statistics here. Here I'm sharing a statistics which is been published by the Liberty Safety Standards. This has been published in US, the Liberty Mutual Workplace Safety Index. They published every year. Uh, we don't have any this type of index in India. I hope we can have this type of index. This is very, very effective index. Um, the last year, 2019, the Liberty Mutual Workplace Safety Index, which has been published, that has shows that the federal, the industrial area, they almost lost almost uh, 55 more than 55 billion of dollars because of workplace injuries. And out of that 55 billion of injuries, almost 46 or 47 billion of injuries comes from particular 10 type of injuries. Out of, you can see this 10 type of injuries are listed over here, and out of that, the very first, which is almost 24% of the total injuries, that is overextension. What is overextension? Overextension means overreaching, overlifting. We are doing above, we are performing above our working ability, physiological capacity when we are performing the job. This is the overextension, overreaching of our work. So the federal statements has showing that the overextension, overreaching of work is cause the maximum injury in their level. So this information has been derived from the Liberty Mutual's statistics. They have a BLS statistics. They have other work intensive statistics. From there it's been derived. So I'm not going in detail, just I have shared this information with you. And we have to think about this type of statistics should be available in India also. Uh, Now, this workplace injury, among the workplace injury, there are a lot of different kind of workplace injuries are there. As I'll be talking about the lifting characteristics, lifting risk. So I'll be concentrated with the manual material handling aspects. And when any kind of work, any kind of working activity we are performing, definitely we are going for the manual material handling. And if we consider the agricultural field, definitely in Indian context, still now, it is almost 95% is manual material handling. Very, very nominal automations are there. Even automations we apply, the automations are also having various hazardous aspects. I'm not going to discuss that part. So manual material handling, they're giving the musculoskeletal disorder. I hope that musculoskeletal disorder has been discussed, but I'll just just very fast, I'll talk about some of the points. We have a lot of very different type of musculoskeletal disorders, but out of that, the very common is like cumulative trauma disorder, repetitive strain injuries, repetitive motion injuries, carpal tunnel syndromes. There are various different kind of musculoskeletal disorders can be found. So if you see the definition of the musculoskeletal disorder, there are a lot of different definitions have been prescribed, but I'll be just sharing a definition which has been taken from the Bureau of Labor Statistics and Department of Labor of Federal State. So they are saying that musculoskeletal systems and connective tissues, disease and disorders, when the event or exposure leading to the case in bodily reactions like bending, climbing, curling, reaching, twisting, or the overextension or the repetitive motions. So exactly we are doing some activity, when we are performing some job, if we are frequently going for a bending postures, if you are climbing, if you're curling, overreaching, I'm here now, I'm using, most of us are working from home, and in my house I don't have that much facility what I supposed to have in my office. So when I'm overreaching, I'm not getting some stuff in my table, and I'm overreaching and I'm jumping on some that monitor screen. So these all such of overreaching, overextension, repetition, this will be potential factors for creating this musculoskeletal disorder. But it has to be identified that musculoskeletal disorders will not be included when a person is met with an accident like sleep, trip, fall, or similar type of incidents or accidents they met with that. And because of that incident, if they developed a discomfort, injury, so that will not be considered as a musculoskeletal disorder. So mostly the musculoskeletal disorders will consider like a sprain, strain, tears, back pain, which is very much common nowadays, and the carpal tunnel syndrome. Before going to today's main topic, I'll just, with the bird's eye view, I will talk about some of the information like the health is the very important definition, and when you are deviating from the health, we are getting the disorders. So in that, we can say the disorders, the definition is variously defined as an alteration in an individual usual sense of wellness or ability to function. So whenever we are deviating from our normal health, so that can be a disorder. The disorder can may or may not be interference because of the usual activities or daily living or work activities. It's not that every work, every time, whatever you're doing, that will cause your disorder. Disorder may or may not be associated with your well recognized anatomic, physiologic, or psychiatric pathology. So it can be happen because of particular work, particular point of work, and because of particular person's well-being, it can be affected. And simultaneously, when the disorder, we need to know about the injury also. Injury is defined as a full continuum from the most minor of the tissue irritation to the grossest of the tissue failure. So minimum minor irritation of the tissue, that can be also taken as an injury. And pain, we talk about the pain a lot of the time: back pain, shoulder pain, neck pain. It's an unpleasant sensory and emotional experience associated with the actual or potential tissue damage, or described in terms of such damage. So definitely the pain is not only a physical or unpleasant sensory part, it's also a emotional experience. You will get a lot of time. If it is actual or potential tissue damage, then also you will get this. So these are the basic information we need to know. But still, we cannot forget our body. Our body, basically the musculoskeletal disorders, when you are talking about, mostly we talk about the three commonly affected organs. But this the musculoskeletal system is consists of like muscle, tendon, nerve, ligaments, joints, cartilage. These are the very, very common 6 component of the musculoskeletal system. Apart of that musculoskeletal system, this muscle, tendon, nerve, ligament, joints, cartilage, there are another one very important part is the spine. See, the overextension, over attempting and working above the physiological capacity, definitely the physiology of the muscle will be altered. A lot of biochemical components will be altered, that will be definitely increase the lactic accumulation, fatigue, and other way, and chronic effect of this will be definitely promote towards the musculoskeletal disorder. The exertion, stress, strain can affect on the tendon. The compression can affect on the nerve, ligaments, and the overreaching, twisting for a longer time can affect on the joint, cartilages. Spines, definitely the one of the very important area for the back pain. The not maintaining the normal curvature of spine. Normally, we all are having a S curvature. If you go to the lumbosacral region, you will see a internal depression. So this is maintaining the normal S curvature. But whenever we are working nowadays in computer also, we forget that, and we just stooping forward. We try to overreach on our screen, and this A shape is deformed and it's form a C shape. So in the lumbosacral region, where you should have a depression, that become a U shape, or it's completely give a C shape. So when this spine change, that's gives a lot of complications, slip disc, and various like chronic disorders like back pain, and in future also the people not able to stretch properly. So these are there. It's, you need to know about our body, how and why we are getting this. Now I'll come first for the ergonomics risk factors. Then I'll go for the individual topic. I'll go for the NIOS lifting equations. Today this is our main topic. We'll learn how to calculate the load, how much load an individual can carry, and how they are carrying the particular load. They're getting any stress, any hazards from that or not. We'll calculate that. That I'll go later on. First, we'll see what are the various ergonomics risk factors are there. The first and very important factor is repetition. In ergonomics, we say if you do a particular work for 50% of the total work cycle is called repetition. So like almost all of you have seen the blacksmiths. Those are hammering, and by hammering, they're transferring the small metal blocks in various components. Even the goldsmiths, particularly these blacksmiths, goldsmiths, is my working area. I'm working in the informal sectors. So these people are hammering. Might be this is a very precision hammering, or it's a heavy hammering, but they are doing. So we can see 70 to 80% of their work is only hammering. So this is a repetitive job. So they are doing the repetition. So that repetition is definitely going to cause a musculoskeletal disorder. This is definitely a ergonomics risk factor. Then how we are holding the various handles, various objects, even in agricultural field, when we are handling the shovel, when we are handling the rigging tools. So this holding activity, so you are twisting your wrist, you are deviating from the linear postures, anything, this type of conditions will be what is doing, it's compression, is giving the compression, is giving the strain to the nerve, to the tendons. So you are holding for a longer time, in an awkward posture, that's going to definitely put a risk on your body. Force, that this is a very if you go back to the physics, whatever we have given force, that is coming back to us. So the biomechanics has a very good explanation. So when these blacksmiths are hammering, when they're hammering with the force, that force will come back to the muscles and the joints. So the force is definitely acting on your musculoskeletal system. Awkward postures, I already gave an example of like back, how if you are not holding a back straight, and if you're not maintaining the normal curvature of back, so that's going to put a stress. There are various context stress are there, like in which area you are working, is it area is hygienic, or any microbial infection, or any other external hazards are there or not. Then vibration is also very important. Then temperature, environmental hazards, environmental risk factors are there. Hot and cold, both the environments are extreme hot and extreme cold. Both the environments are not good for our physiological system. So any hot, any extreme cold temperature will be altering our normal physiological activity, that will be altering the physical capacity, physical work capacity. This is very important. If you cannot force a worker to work beyond the physical work capacity, the moment they are working on the beyond the work capacity, they are going to get a stress, and that can be a risk factors. Then this is very, very important in Indian informal sectors, lack of rest between the tasks. If you see the OSHA or NIOS, they are variably, even today what we are going to discuss, the NIOS lifting equation, they are variably saying that these all standard, these all equations are for the working period of 8 hours. But very interestingly, in Indian scenario, the informal sectors workers are working more than 8 hours. More than 8 hours. And in a particular season, like I'm working on the goldsmiths for almost 10 years. They are working 12 hours, 13 hours per day. So how can we implement this NIOSH or OSHA guideline on them? So when they are not using the 8 hours working pattern, so they don't have proper rest pattern also. So these are the risk factors. These are the various ergonomics risk factors. And now today, whatever I am going to discuss, these are basically federal standard, US standard. And the federal standardization for the Occupational Safety and Health Act, they give the empowerment to the NIOSH, which is known as National Institute of Occupational Safety and Health. So they give the empowerment to this NIOSH to prepare a recommendation, and that recommendation can be followed by the various industrial sectors. OSHA is also establishing various guidelines. NIOSH, whatever the recommendation they are giving, these are not enforceable by the law, but they have various compensation act, labor welfare act, factories act, which is giving the support to the workers to get benefited by this. But in Indian context, this is a little bit difficult to have, but you can get it from the organized sectors. but as Asian and Indian context is more than 80 to 90% workers are involved in unorganized or informal sectors. So difficult to get these benefits. So NIOSH is doing a lot of various methods. They are preparing, they are giving the guidelines. But today we are going to discuss about the lifting index and recommended weight limit. Recommended weight limit. In agricultural work, a lot of time the agricultural workers are involved in weightlifting, lifting the loads and from the ground level, and they're shifting the loads in trolley or any other heighted position. So this lifting weight of like various fertilizer, various crops, various other instruments. So in that sector, you can implement this NASH lifting index, and recommended weight limit can be implemented over there. So OSHA is also a part of the Occupational Safety and Health Act by the Federal Bureau. So they have Act 1970s Act. By that they form Occupational Safety and Health Administration Committee. They basically ensure the safe and helpful working condition for the working sectors, that irrespectively for the working men or working women. And they're giving the standards. What standards they're getting from the NIOSH? They're getting the standards for by various rules and training methods to the various working sectors. And as this OSHA is a part of United States Department of Labor, so they have the power to enforce this guideline to the community. So that way this can be formed as a rules also. For the assessing the various ergonomic risk factors and ergonomics task, there are various assessment tools are there. For the vibration, hand arm vibration calculators are there. Pushing, pulling, carrying activities can be assessed by the SNOC table. Already, I think the entire body posture and upper body posture assessment, like RULA and REBA, has been done, I think, in yesterday's session. So the left one is the lifting and lowering the activity. Basically, for the lifting, Visha lifting calculator or the NIOSH lifting equation is very effective. So today we'll be talking about the NIOSH lifting equation. Sorry. NIOSH, this, as already we said, that this is a National Institute for Occupational Safety and Health. So they developed a lot of guidelines. Out of that, they developed the equation for calculating the recommended weight limit for a particular, for an individual. So that they give that formula, that they give that guideline. So what we can identify the recommended weight limit for a particular work, particular job, and that should be accepted, that should be adapted in any kind of work, because it will be very effective to reduce the stress during the work, and it will reduce the risk factors to develop the low back and other musculoskeletal disorder. This equation is determined in a very empirical way. It's having the specific weight limit and specific variables during the weightlifting is considered. So you can see here the person is lifting the load, is not only lifting. So it's not we are just lifting the load and leaving that. We need to lift, we need to adapt the various posture, we need to change our position, we have to shift the load from one level to another level. So there are different kind of movement, vertical, horizontal movement, that rotation of angles, a lot of activities will be done. This NIOSH, the lifting equation, has been developed in the year of 1981, long back. But this has been modified in 1991. So today, whatever we are going to discuss, this will be discussed as the modified NIOSH lifting equations. The modified NIOSH lifting equations is basically adapted in the British measurement process. They took the pound and inches, but it has been converted in our Indian standards also. We will consider as a kg as a load, and we'll measure the distance in centimeters. So NIOSH has given already a recommendation for an adult person to work. So the recommended weight load will be 23 kg in a particular condition. What are the particular condition? That work should be performed in a sagittal plane, and the weight what we are lifting that should not go above the 75 centimeter, and that weight should be lifted from a height at least 25 centimeter from the floor. It should not be almost the ground. We should not lift that. The load should be lifted not more than this like 25 centimeter, and it should not go above the 75 centimeter. But if it is go, what will be happening? Definitely it can go, it goes a lot of time. So then it's deviate the standard 23 kilo lifting recommendation. So that will be reduced. So we'll come to that point. Then we need to have a proper holding or coupling system. That means what load we are lifting. So if you are lifting a big stone, and if you are lifting a proper crate, in agriculture field you will find the crate, so they have a proper gripping system. The two things is too different. When you are having a proper gripping coupling system, so that will be reducing your stress dealing with the load. And the frequency of lifting the load is also very important factor. If you are lifting the load very frequently, so it's almost more than 10 12 per minute, it's highly risky job. You should immediately stop as per NIOSH. So these are the conditions. It can change NIOSH recommendation, primary recommendation, that recommendation for weight lift, that is 23 kilo, that can be changed. So how to calculate this particular recommended weight limit for a particular work, and we need to see that this is accepted or this has been used properly or not. So the two things coming from the NIOSH lifting equation, the two outputs there, one is the recommended weight limit, or we'll be saying it RWL noun. So is this weight too heavy for the task? We have to find out. This is the answer. And then lifting index, it is giving answer the how significant is the risk. So first of all, you have to identify the what is the recommended weight limit for the particular work. Then you have to see the your worker is working in a particular system where they are following this recommendation, or if they are not following the recommendation, how they are deviating and what way they are getting the stress, what way they are getting the risk. So that we have to evaluate. So so to identify this NIOSH lifting equation and the lifting load and stress in this all can be measured by the 6 coefficient. The 6 coefficients are very important. So not only load. So NIOSH has given a recommendation of 23 kilo will be the recommended load to handle for the person, adult person. And definitely I'll say that NIOSH, when they have did this, they developed this equation, they consider the female community those are working. So almost 40% of female worker strength they have considered, and then they prepare this equation. So the recommended load can be influenced by the 6 coefficients. What are the 6 various coefficients? The 6 various coefficients have been determined from the biological models, spinal loading, the various epidemiological factors, psychophysical studies. From that, the coefficients been derived. So we have to identify these various 6 coefficients. We'll definitely go for the methods, how to identify the coefficient, how to calculate the load, how to calculate the risk factors. We'll calculate that today. But this calculation can be done for a single task and multitask. So I'll be discussing single task. Multitask we'll discuss sometime later. Today we'll not go for the multitasking measurement. We'll discuss only the single task measurement. So even for single task, there are 2 points. One when you have starting the work and when you are stopping, ending the work. So we can go for the both the condition also, and we can see the which condition the starting point is having risk or ending point is having risk, that we can measure also. So the six factors what we are going to discuss today, the six factors we'll see by this diagram. You can see here. The six factors we can see. The first factor is the horizontal distance. What is the horizontal distance? So see, you can see this diagram here. This person is holding a load. This is the load. Okay. This load is how far from the body. Okay, that is the horizontal distance. The load is holded how far from the body. There are certain points are there. I will be coming for that point. Then the height what we are dealing. So from where you are lifting the load, what is this position, so this is exactly called the vertical position. This is the vertical position 1. Then we have the vertical distance. So from here you lifted the weight and you shift it here. So this is the vertical distance 2, and the distance of the handling the load, this is this. So 1 is the horizontal, 2 is the vertical distance. Then vertical distance is from the floor, in which distance you are holding the load. Then you are shifting in a particular point, that is the V2. So V2 minus V1, you are getting the distance. Now the time between the lift and frequency, or the how many times you are lifting this, that can be calculated per minute. This will be calculated per minute. How this will I'll discuss later. Then very important is, see, this is the footprint. This is the over this is the top view. You can see. So from top view we can see the footprints, and we can see how this person is moving. So they're holding the load from one point, and they twisted by the spine. So how much degree they have twisted. So the degree will be, or angle will be considered as another variables. Then the grasping or the coupling, here the hand is holding this load. So how they are holding, how comfortable it is, or how poor it is, or how good it is. So that standard also considered over here. This is also another one variable. This is known as coupling variables. So once more, we'll see a little bit of proper way. So how far you are holding the load or weight from your body, that is the horizontal factors. From which point, vertically, which point you are taking the load, that is your vertical distance. From that point up to which point you are shifting, that is another one vertical point. This is vertical point 1 and this is vertical point 2. So vertical point 2 minus vertical point 1, we are getting the distance you are handling the load. The frequency or the time interval, how long, how frequently you are working, that is there. Then the asymmetry or the rotation. So you started lifting the load in this point, and then you shifted here. So you can see this is your center of axis, and this movement is done according to this. So the angle, the 90-degree angle rotation is there with your spine. So this is also been calculated over here. So normally when we are using this Nash lifting equation, there are certain already it has been recommended that 23 kg is the recommended load or weight. So this recommended load or weight will be at a good and favorable condition if we maintain some of the points. So these are the favorable green zone where you can easily say that yes, 23 kg is accepted load. What there? So if you hold weight or the load close to your body, normally not in a flex condition, normal in a belly condition, if you position, if you hold the load at a wrist height, so it should not be flex your arm and it should not lift. It should be hold like this in a wrist height and in a belly position. Don't move so much. If you're moving, if you're twisting, that is giving a stress. Infrequent lifting, so you cannot go for a frequent lifting. Frequent lifting should not be there. Move with no twist. You can little bit move and go and put the load in a other platform, but without twisting. Whenever you are adapting the twisting, so that is giving another stress. Then finally you are holding a any object. See, I have a small tab in my hand. This is very, I can hold like this, but instead of that, if I have a like a parcel which is having 10 kilo weight, I cannot hold like in one hand, or I cannot just somehow I can hold this. I have to hold, I need a good grip. So this grip is good, then this is perfect for the 23 kg load is perfect. So if it's not there, if it is deviating, definitely some other complications will be there. So we'll just see some of the videos, by that we'll see how these factors, the 6 factors been calculated, and why these 6 factors are so important, that we'll see now with this point. Okay. One minute, this will take some time. There's a videos take some time. Okay, I think now it's coming. So there are certain points are there. So when you are just lifting it up, it's horizontal away from, it's lifting it up, it's a vertical. When it's taking away from your body, the horizontal. When you are taking its, so this is, you can see here, you are taking the away from your body, the weight. This is a horizontal reach. So how far? So from the central axis. Then from the wrist level, if it is taking down or taking up, so that is a vertical height. So where you are taking, where you are lifting, then from that particular lifting point, how far you are taking up or how far you are taking down. So this is the distance. Then for how long you are holding the load, how long you are lifting the load, so how far you are performing this work, these all we consider as a frequency or repetitive factors. Then you have the crisping. So sorry, this is, you have the asymmetry. So how you are twisting from the central axis, this is your central axis. From that, how far you are twisting, the angle or degree. Then the coupling, the griping grip condition. If you are holding in a proper box pattern, if you are holding in a round object, if you are holding a bag, so which one is best, which one is having better grasping. Which one is better coupling factors? So if you have a better coupling factor, definitely that is going to reduce your risk. But like a round object, a bag, a sandbag, or any other crops bag that's not having proper gripping. So when you are not having the proper gripping, so definitely it's going to increase or going to add some of extra stress on you. Now we'll see how these factors, when it's changing, it's putting the stress. So mostly the 23 kgs, which has been standard from the national lifting equation, that is at per the your all factors, all 6 factors supposed to be in a 100% range. If this is deviating from this 100% range, so definitely this 23 kgs is not advisable, and that recommended load will be reduced. Now we'll see here how it's happening. The 100% will be acceptable, 100% is supposed to be there. Now we'll come for the horizontal reach factors. So where we are lifting the load, so it is away from your body. When you are going away from, it is reducing from 100 to 60. You are going furthermore, it's reducing 40. If it's going furthermore with twisting your back, neck, shoulder, it's 0. You should not perform. And why? That is because your back, shoulder is getting stress from that, but the vertical factors. How far you are lifting the load from your wrist level. So if it is their wrist level, 100%. Now if it is taking from the knee level, it's reduced 90. Go furthermore down, it's 80%. It's reduced your vertical factors 80%. So from the floor, you should not take. Why? Your back bend twisted, your back being forward bended. The extra stress is happening in the back. So you should not lift the load on your shoulder point or above the shoulder level. Again, this is again not acceptable because it's giving a stress on your shoulder position. Excessive down, back, excessive up, shoulder. Now the distance where you are doing, if you are doing a little bit of like in your with the body axis, if you are close to body, okay. But if you are lifting the load from the down, if you are putting it up, so it's reducing the 100% from 90, 80%, dropping. The distance factors is dropping. So when it is factors is dropping, definitely that is not acceptable. The frequency, if you are lifting very minimum 1 lift per hour, this is very good. Actually, Nash says that you lift 1 per hour, 100%, but you lift 1 per minute, it's reducing 90%. You're lifting 5 per minute, it's 80%. You are lifting 12 per minute, so that means in 5-second one. So Nash is saying it's like extremely hazardous. You should not perform this. So you can see, even you are having a 23 kgs, if you are lifting for the 12 lift per minute, it's not advisable. Then the asymmetry, how you are rotating. So when you are holding the load with you, no problem, 100%. You are twisting in the 60 degree, 70 degree, 135 degree, your asymmetry percent is reducing from 100 to 0. Now coupling factors, how you are holding, you are having a proper gripping. If gripping is good, it's 100%. Proper grip, proper handle, good. If you are holding, it's not grip, but if you have a small objects or you can hold like this, good, 100%. But if you have a sandbag, if you have a round object, you are not having the gripping properly. So your 100% will be reducing. 100% is reducing from the 100%. So that means 23 kg is not still the ideal load for you. So these factors need to be understood and we'll need to consider. So now from this point, we'll discuss how to calculate these loads. We'll be calculating this load. How? First of all, the first factor, the horizontal location. Now the horizontal location, as I said, the length or the distance of the load of the weight from your body. Now the point is, which at the point you should calculate, So now if you make a straight line, central axis, you have to make that, and you have to make a central axis of the load. So again, we go for the top view. This is the 2 footprint, and we can see this is the midpoint. This is the midpoint of the position. So this can be the central axis of that particular moment of that particular person. So from that point, we need to go up to the central point of this load. So that means the knuckle point where we are gripping this. So as we are doing this in our Indian standard, so we'll be using the kg, and the distance we need to be measured in form of centimeter. Will be forming centimeter. In British standards, they will be doing the pound, and they will be doing in inch. So you got to know that how to measure the horizontal location. This is very important. You have to take the midpoint of the two inner ankle bones. Two inner ankle bones, you can see these two inner ankle bones are there. So make a line, and the central part, this you have to take, and the central point of the horizontal position of the load. So the knuckle point. So you have to calculate now this distance. This distance will be your horizontal distance. Now the vertical location. Now again, the vertical location. What will be the vertical location? So vertical location is from where you have taken. So this one. So again, the knuckle point, this knuckle point you have to measure where you are holding and from which point you are taking this load. So this is one point. This is your vertical location of the hands. So measurement of the vertical location will be there two times, in origin also, and in destination also. As I have said, this is the vertical 1, vertical 2, or we can say VO and VD. Some places they write VO, VD also, or V1 or V2 also we can say. So by that way, the two part we have to see. So one point you are getting this is your V1, and again this is you are doing the V2. Again, this knuckle point you have to measure from this distance. Okay. So now when you did this, so the another one derivative you have to calculate, that is the vertical travel distance, or the distance, exactly the distance you have put here in the V1 and the V2 already, then origin and end of the work. So this 2 V2 minus V1 will give you the vertical distance what you have traveled with the load. The vertical distance what you have traveled with the load, that can be derived from here. Next is the asymmetric. Next is the asymmetric angle. Asymmetric angle is exactly the rotation, the twisting of angle. So see, this is when you are holding this load here and you shifted here. See, you are shifting from the central axis. So here you have to make a plane, here you have to make a plane, and then this you have to calculate the angle. This angle you need to calculate. So this is almost 90-degree angle. This is also 90-degree angle. The rotation of trunk is almost 90 degree. So we are calculating this. So this is the asymmetric angle. Now the coupling is exactly with your quality of the load or quality of the objects you are holding as a load. So that object is having the proper good or fair holding aspects, is having a proper grip or not, that is considered here. So if you have a proper gripping, so definitely that will be reducing your stress and strain during this lifting activity. What we can say the good is the optimal design when you have a handle or any other objects. So this point is very important as a ergonomic design point of view. By implementing the ergonomics design, you can have a very proper handle design. The handle can be, again, the designing the handle, a lot of consideration will be there. If you are working for a longer time and Indian subcontinent condition, the gripping should be a proper, which will not create a much more sweating. If the sweating is there, then there is a chance of slip. The grip, if some people are working in furnace or any other area, the grip should be having an insulator. That should not be metallic. That should have insulation also. Then the grip should not put extra weight for that object, that also be considered. So this different way, different handle designs, it can be done. So So if you are lifting a weight of like a mug, so the handle will be different. And if you are lifting a bucket, the handle will be different. So this is the concept of ergonomics, how you're handling the load that need to be measured. So by the measuring, this is a little bit of psychophysiological aspects. If the measurement is good, if it's not good, it's a poor, if it is fair, then we can grade them. And by grading, we can add some extra point. Then the frequency is definitely, like we have seen that now she's saying the 23 kg is standard for the one lift per minute. It's not possible. So we have to measure. So how to measure? You have to measure the lifting activity for 15 minutes. You calculate that lifting activities for 15 minutes, then divide that, the number of lifting activity divided by the 50. So that way you can calculate this frequency. Then the load, definitely we have to measure the load. For measuring the load, we have determining the various weighing activity. We have to weigh the load. So that way we'll get the exact load what we are handling. That means the load I am talking here, the load the particular worker is dealing with, that load. So that load we have to measure. Then duration need to measure. NIOSH, they give this equation, the standard that they gave for maximum 8 hours work. Anything more than 8 hours, they are not giving any suggestions. So they classify the work in 3 categories. Short work, that you are working or lifting for less than 1 hour in a day. Moderate, lifting between 1 to 2 hours. And for long time, between 2 to 8 hours. Now, very interestingly, I'll give one example. Like you have a worker who is lifting a load for 30 minutes. Then go for a pause for 20 minutes. Then go for again lifting the load for 45 minutes. Now what we will consider this? We'll consider this as a total 45 plus 30. So it's 100. It's a 1 hour 15 minutes. So will we consider it as a, like it comes under the second moderate work, or will it consider as a short work? So will it take it as a 30 and 45? It is less than 1 hour. But if we combine this, 30 and 45 is 1 hour 15 minutes. But the person has taken a 20 minutes rest. So what should be considered? Yes, definitely it should be considered as a moderate work, because the rest pause is not symmetric. For this, the rest work should be, if someone has taken a 30 minutes working hour, so after 30 minutes of job, they should go for 1.2 multiplied by 30. So it comes around 36 minutes of rest. So instead of 20 minutes, if he or she could have taken 36 minute rest, then after that, if he or she could have gone for the 45 minutes lift, so we could have taken it as a short lifting. But if they are not doing that, then it will become under moderate. Similarly, in moderate, if someone is doing for 65 minutes and then they go for the 75 minutes. So what will be? The gap should be here a little bit different. It will be a little bit different. It can be recovery time. So these are called as a recovery time. So till these 6 factors, what I have mentioned, and I have mentioned how to record that. That's recording is very important. How we are recording the horizontal location. It's not that we'll take it from our surface. So the weight is, the load is there, I will take from my chest surface. No, it should come from the central axis, because your center of gravity will be deviate. You know, when we are when we are holding a load far from our body, our center of gravity go away from the body. So you need to hold the load from closely from your body. So you are taking away. So you have to take the central axis, and from that you measure the horizontal location. So you have to do this. So these things you can do here and do here, origin of the work and destination of the work. The vertical destination, that is the V1 and V2. The distance travel will not be, it will be combined, V2 minus V1. The angle, the degree of rotation you will take. The coupling, you need to identify. This is a psychosocial aspect. This you have to identify this 1, 2 or 3. By that tabulation is there. Then frequency, definitely you have to measure the lift per minute. The load, you have to calculate the load. You can do see, this has been found that a lot of the working area, the load is not constant. They have gone for the variable loads. So if you are going for the variable load, so you have to make a two column sorry, you have to make a two column. One is the average load lifted and the maximum load lifted. Thank you. Sorry. So the two loads you have to measure. One, the average load. So suppose in a work cycle they are taking 3 different load. So you take the average of that. So that will be coming here, average, and the maximum. Which one is maximum? So suppose this is maximum. So this maximum will come here. And the duration, how long they are performing. Already we have seen that how to calculate. If it is less than 1 hour, if it is more than 1 hour to 2 hours, and if it is more than 2 hours to 8 hours. Up to 8 hours can be calculated by this. This is the limitation for the Nash lifting equation, because most of the equation they have made as per their federal standard, not for Indian standard. So now in 1991, the equation. So we have collected the data, the various factors we calculated. We have calculated the horizontal distance, we have calculated the vertical distance, we have calculated the total distance travel, the asymmetric distance, then the frequency, the coupling. Now we'll be having the multiplier. What is the multiplier? The recommended load. We have already a recommended load. This is the recommended load, 23 kgs. 23 kgs is the recommended load. Now the multipliers are what? Multipliers are these different 6 factors. These multipliers basically reducing your load. If the multiplier factors are increasing, they will be reducing the limit. So actually here it will be getting the multiplier, horizontal multiplier, vertical multiplier, distance multiplier. They have an equation. What are the equation? The 25 minus your horizontal distance, the centimeter in centimeter, whatever the distance you got, that will become as a 25 divided by vertical multiplier, 1 minus this fraction mode of this vertical distance minus 75. By the help of mode, what is the usefulness? So if it is 60 minus 75, if it is 60 minus 75, what is coming? It's coming minus, sorry. Okay, ignore this. So if it is coming minus 315. Now if it is coming 90 minus 75, again it is coming 15. So because of this mode, it will be same, so no minus. So this is the another one equation. Then distance multiplier, that is also having fraction 4.5 divided by the distance. The distance is a V2 minus V1. Asymmetric multiplier, that is again having the equation, this 0.0032 multiplied by the A, the angle. Frequency multiplier and the coupling multiplier will be getting from the table. This is the table we have. This is the table we have. 1 minute. This is a table we have. By this table we can get the frequency multiplier. How we can get the frequency multiplier? So lifting per minute. So there is a minimum lifting is there. That is also given by the NIOSH. The minimum lifting should be 0.2 per minute. That should be there. And then in other hand, they have given the maximum lifting also. It should be 15. So 15 per minute. So if this frequency is sustained less than 1 hour, and if the vertical distance is less than 75, what will be the score? If it is less than 1 hour, 1 hour and or same to the 1 hour, that means the minimum work cycle. And if this vertical distance is more than 75 or 75, so then what will be the score? And that way we can calculate for the 2 hours, 8 hours. For the coupling factors also we can get this point. If the coupling is good, if the coupling is fair, if the coupling is poor, that can be calculated from the, if the vertical distance is less than 75 or if the vertical distance is with 75. So after getting that, we will be having this equation. This will be the equation. So recommended weight limit, how we can calculate? So 23 multiplied by this various multiplier. How we will do this? I'll be having an example and there we'll be calculating this, how can perform this. No issue with that. So the lifting index is what? Lifting index is the ratio between the actual load and the recommended weight load. So what that recommended weight load is saying 23 as in a normal condition. I am not going for the various multiplier. And in a ground reality, the worker is using 40. So 40 divided by 23, the ratio between the actual load and the recommended load. So what is coming? That is called the lifting index. And if the lifting index is less than 1, then it's perfect, no issue. Even it is go up to 1, okay. So 23 kg, so 23 kg easy, no issue. But if it is more, now you can see this is 40. It is almost double. So this is not a good condition. Then we have to identify what are the factors, what are the point we need to give the ergonomic intervention. If it is goes up to 3, immediately that need to be removed because it's a high risk condition. So the lifting index is a recommendation to identify your risk at your particular working condition. You can identify the risk. The factors what are contributing for the risk, that is the lowest multiplier value. When we will go for the calculation, that part, that time we'll see this part. The lowest multiplier value, how we have to identify, and how we have to identify which is the most risk factor. Now we'll just see very fast. I think, ma'am, I'll be having how much time? Another 10 minutes I can take? 5 to 10 minutes?
Yes, you can take 10 minutes.
Okay. So when this equation cannot, yes, this equation is having some limitation. So when this equation cannot be acceptable, so they cannot be acceptable with like one hand use for more over 8 hours. As I already said, they have a limitation up to 8 hours job. When we have seated or nailing, and that condition we are doing work, basically the agricultural worker, when they're weaving, when they're reaching, so that part when they're sitting in a stooping posture cannot be controlled, basically the lifting the load condition. Restricted workplace, that, and mostly the what load they are handling, this load is not stable, it is unstable work. If they're pushing, pulling, if they're using the wheelbarrow, so these are not be considered. Extremely hot environmental condition, definitely that will be changing the physiological activity, so that will not considered here. Physiological consideration is not here. So we have to remember that this NIOSH equation has been performed on the American and European population, and when we are going to apply it on our condition, so definitely 23 might not be the preferable workload. Those are working in Rajasthan in summer, or those are working in our central India. So we cannot say them 23 kilo they perform for 5 hours, 6 hours, 2 hours, like that. Even it is 8 hours, under 8 hours, we cannot say, because in this equation there is no consideration for your environmental factors. Someone is having the bad instrument, bad objects, and that it will not be considered. When this can be considered, equation can be used, very much useful when we are basically handling the load with two-handed lifting, comfortable lifting posture, comfortable environment, basically the European and American environment, not tropical environments that have been considered over there. Yes, tropical. So what we should do, we should not use a lifting equation. Yes, we can use, but we have to keep in our mind that there is a extra stressors and they are the environmental stressors. Already we have discussed that this is an environmental cold and hot temperature, the another risk factor. So we have to consider that if we get a recommended limit as a 25, we should not force our worker to go for 25 kilo. So we can little bit give some reduction in that. So this we can do. And now we have another one. This is the last one. I think no issue with this. Somehow it's not working. I'll come later on this part. This is like a one video is there which is exactly the showing that how to hold the grip and how it's not working. So we'll just calculate first, then we'll go this is an example I'll be talking here. So here we can see one person is holding a load and need to shift here and with rotation. So here the horizontal part, it is 45 centimeter. We have measured this. The vertical part, it is 60, and the distance is 70 centimeter. The angle we measured, this has been found 45. And frequency, we found that 3 times per minute with 8 hours activity. And the coupling is good because it's a square object, the coupling is good. So now how we will be calculating? So as we already found that horizontal location is 45, vertical location is 60, travel distance is 70, asymmetry angle is 45, coupling is good, and frequency is 3 per minute. Average load, okay, average load is 12 kilo and working for 8 hours. Now this is the distance. Now how to calculate the multiplier? So this is the equations are there. These are the equation. So load is 23 and the horizontal multiplier, HM horizontal multiplier will be 25 divided by, you can see 20, this is 25 divided by 45. So that way we are getting this. Vertical multiplier we are getting by this. This is the equation. In V, in place of V, we are putting the 60. Travel distance we are having this 0.82 plus 4.5 divided by D, 70. The D, in place of D, we are putting the 70. We got this. Now angle asymmetry 45. How we got this? In place of A, we are giving this 45. We got this. Now coupling, as I mentioned, it's good. So how we will be doing this coupling factor? If coupling factor is good, so here is the table. If it is good, and the vertical location, if it is less than 75, so then what will be the factor? It is 1. So we put that 1 is right. Frequency 3 per minute. So frequency 3 per minute will go for here. Yes, this is frequency 3 per minute. This is the table. And it's performed for less than 1 hour, less than 2 hour, or less than 8 hour. 8 hour. Okay. So now what will be the tabulation? It is, and vertical is less than 75. So the value is 0.55. So when you got that, we will have this calculation. This is the formula. What is the formula? Formula is these will be, these all will be multiplied with 23. And how what we got? We got this 5.08 kg. So now we can see what our worker was using the load. He or she was using the load of 12 kg. But adapting the various posture, various activity, he or she is supposed to use 5.8 kg load. So this is the recommended weight limit. Now, what is the lifting index? What we can identify from here? The lifting index is very high, 2.36. So how we got this? The exact weight was handled divided by 5.08, that recommended load. So exact load and the recommended weight load ratio. So this is very high. So why this is very high, we have to find out. Now we have to see which is giving the maximum stress. Which is giving the maximum stress. If you see the multiplier, among the multiplier, which one is the minimum? The frequency is the minimum. Yes, you can see. And which one is good? So this one. So this one is a green zone. Coupling is good, but the frequency is not good because 3 per minute. So this is giving the maximum stress. Next, which stress is there? The horizontal location. So the worker hold the load little bit away from the body. You can see this is exactly away from the body. This is giving a huge stress over here. Then what is next? Next one is the angle of asymmetry. Yes, angle of asymmetry is not much, but still 45 degree. 45 degree is there. Then, so what you have to do? You have to arrange this multiplier in an asymmetric pattern. Asymmetric pattern. Sorry, ascending pattern. Ascending pattern is 0.55, then 0.56, then 0.85, 0.88, 0.95. So 0.88 is the travel distance. Yes, the travel distance is also somehow he has to take this much, 70. He has to go for that. So this way we can calculate our lifting activity. So lifting activity can be calculated in this way. And this way, after calculation, we can say which one is the recommended load for that particular person, a particular work. Now, this work is performed in that particular way with that recommended load is putting a stress or not. So how can we identify? By the calculation of lifting index. So lifting, the two things is very important: recommended weight limit and lifting index. So I think somehow I finish this. This is a big chapter and I have completed only one thing, that is the single task. There are multitasker also there, and that is a very important in Indian context. The agriculture or any worker, they are not doing a single task. Single task, this is a can be done in a organized sectors. They are doing just only, you know, that mobile assembling section. The particular person is doing particular work. They're fitting only the camera. They're doing that. That can also have some hazard. That can repetition, but they're doing a single task. But agricultural worker, they're doing multitask. Simultaneously, they are keeping their kids. They are weaving the land. They are putting the seeds. Multitasking. So for multitasking, there is separate lifting equation is there, but for the time concern, I cannot go for that. So hope we will be having in some time future, we will discuss this. But ultimately, what we will say, the safety is the first. As we all are human, we having a physical and physiological capacity. We cannot work beyond that. The moment we are intending to work on beyond of the physical and physical capacity, that will be changing the normal homeostasis. And that cause the various strain and risk. And that if the strain and risk is cumulative, that will be definitely going to make some disorder or injury. Okay, I will say once again, thank you to all, and thank you, Professor Suman ma'am, to give me this opportunity. Thank you all.
Well, thank you very much, Professor Ghosh. You have tried to explain a very difficult equation in a very lucid manner. It was very interesting with your moving figures and all those things. And certainly in agriculture, the workers are multitasker. So maybe everything cannot be finished in one training.
Yeah.
Something to meet for the next one.
A-
It was really
Actually,
great.
ma'am, without knowing the single task, we cannot go for the multitask. So this is the basic calculation.
Yes, yes, I understand. It is the first step to understand, and then we can move ahead on the advanced equations. There's one question which is, I think she must have got the answer by our discussion. The person is asking that in Indian condition, load is usually carried on back and head. Can we use NEOSH in this situation?
See, there are thing is Neosh is that load equation is how you are using the load already. If you have seen my that bar diagram where we were showing that how this frequently this multiplier is acting on the load. So the two aspects of the equation, one we are calculating the recommendation load, how much load you can carry, that we calculate. Now the adaptation of the load, you will be putting a stress. So if you are holding a load along with your body in the rest position, then okay, 23 kg. The moment you are taking the load on your head, this is a very wrong condition, because your the center of gravity is changed. Now your height increase, your center of gravity, you will be not having the stability. You cannot work with this. So we have one work in our Calcutta that is called the Bada Bazar area. They are using 90 kilo, 130 kilo weight on their top. The coolies are there in Bada Bazar. So this was a very unsafe condition. Then we prepare a trolley for them, because the moment you are holding the weight above shoulder level, maximum risk. Now saying that your work, the load carrying capacity is 0. But still in Indian context, they are doing. And back, if how long your back is straight, the Gurkhas, they are carrying the load, they're putting a strip on their head, and they try to make their back straight. You can practice it. If you just stooping, forward bending, and try to walk or keep load in your back, you will not get the stability. But if you straight, when you are climbing the stairs, you try to tend back, so your center of gravity will be in a linear axis. So this is all the biomechanics. When you change your position, this alter your center of gravity, and that cause this.
It's really true that in how much unsafe conditions, or how unsafe is the work of women when they are carrying fuel wood and the fodder on their head, and a lot of manual material handling is there. So we need to have a technology intervention for them. But the problem is, even if we design any hand trucks or any carts for them, the carts even don't work in the
Field.
roads,
Yeah.
the paths, the uneven paths in the villages. So there's a lot of challenge in agriculture.
Ma'am,
Uh,
that's why that when you calculate the NIOSH lifting equation, as I mentioned already, the lifting tools, the coupling format is very important. Where they are lifting, in like suppose agriculture, they are cleaning the ground, and they are holding this all garbage in a plastic pack or something, and they are throwing. This is a very wrong posture. When they're stretching their arm, again, their extension of the shoulder and back. So what they should do, they should have a proper dish which is having a proper handle, and they should go and throw this.
yes,
So
yes.
this type of design we can give them to support and reduce the risk factor.
Yeah, yeah. True, true. So, with your lecture, I'm sure that participants have got a lot of insight, and they'll work in their respective areas and make use of this information. And I'm sure that you are going to be bothered by loads of questions, Dr. Tirthankar, after this session.
No issue.
Uh, So it was really very pleasant. It was very nice that you accepted, and it was very, very useful and very lucid lecture by you. Thank you very much, Dr.
Thank you.
Deep.
Thank you. Thank you, ma'am.
Thank you very much. Well, friends, we move on to the next lecture, which is Dr. Majumdar. Are you there, Dr. Joydeep Majumdar?
Yes, madam. Yes.
Okay, okay. Friends, now we will move to the next lecture, that is on the topic influence of environmental parameters on work performance, assessment measures and methods to mitigate. As in our first day lecture, it was highlighted by me that there are various drudgery factors like awkward posture and manual material handling and lot other things, and one of the important factor was environment, the extreme environments in which workers work. So environment also has lot of impact on the working capacity of the workers. So I would like to introduce Dr. Majumdar to all of you. I'll present a brief bio sketch. Dr. Majumdar, please यहाँ से ढूंढो
नहीं, इनको अनफ्रेंड करना मजूमदार से क्या हो गया?
स्टॉप लाइन
शेयर तो नहीं है।
शेयर कर दो ना एक बार मेरी स्क्रीन उनकी मजूमदार सर की बड़ा कर दो यहाँ से। So friends, Dr. Joydeep Majumdar is presently Assistant Director and Scientist D at ICMR National Institute of Occupational Health, Ahmedabad. He did his Masters in Physiology and Ergonomics from Presidency College, Kolkata, and PhD in Life Science from Gujarat University, Ahmedabad. He has more than 17 years of research experience in the application of ergonomics in industry, agriculture, and office workplace, and teaching in medical, paramedical, public health, and product design courses. At ICMR NIOH, he has been involved in research, teaching, training, and clientele projects in the field of occupational ergonomics. His interests are physical ergonomics, audiometry, heat stress, occupational health, microsurveillance, and health equity analysis. Presently, he is the program coordinator of NVIS project sponsored by Ministry of Energy, what was that, and climate change. He has published over 100 research papers, 100 research papers, out of which 30 papers in peer-reviewed international journals, 16 books, chapters, 11 co-authored. Presently, he is the reviewer of 10 reputed international journals and the editor of a course book for diploma in environment and occupational health program of IGNU. One of his co-authored data book on farm equipment design is a bestseller among production designers. He is a visiting faculty to National Institute of Design, National Institute of Fashion Technology, Indian Institute of Public Health, Manipal University, National Institute of Technology, Surat, and Ganpat University, Mehsana. He is also the member of PM Council on National Action Plan for Climate Change, Human Health, Handicrafts Technology Mission for Export Council for Handicrafts, trainer for OSHA's 18001-2007, and a certified assessor for COSHH risk by International Association for Chemical Safety. He also holds several administrative positions in this institute, that is at NIOH Ahmedabad. So we extend a very warm welcome to you, Dr. Joydeep Majumdar, and The floor is yours, Dr. Majumdar, sir.
Thank you, madam. Thank you.
We are just unpinning Dr. Ghosh and we'll let you in. Just trying to do how to do. Yeah, you are on the screen now. Yes.
Okay. I should share screen now.
Yes, sir.
Yeah. Yeah. So thank you very much, madam, for your generous spoken words. So it's nice to be with you all in this program. So thank you very much for giving me this opportunity. So I would like to be speaking on the environmental part. Yeah. So is it visible now?
Yes,
Yes.
please. Yeah, full screen here.
So I'll be talking about the environmental part, particularly the extreme heat at workplace
Okay.
and the adaptation plan which is required for the workers, and particularly emphasizing on the innovations to combat this heat stress among the individuals. So as you can see in this image only, it's a very difficult workplace that we are speaking about in different occupational health settings. And this is a very common thing that we see at different workplaces. So in these conditions, so practically all type of ergonomic inputs really practically doesn't work. So we do not find that everybody is having the optimal workload as well as optimal working conditions at their workplace. So they are in a very difficult situation. So what we could do in these conditions is to manage the amount of problem, particularly in relation to the weights as well as the workplace temperature, the noise, the other important factors of ergonomics to be little conducive to their end, so that they can be little better handle the situation and work for a longer life during their work schedule. So it's very common that we see everywhere that it's the average temperature is rising. So it is rising by, as I have already given my lecture note also, that the temperature is rising and the surface of the earth is getting heated day by day. So in these conditions, the extreme heat is going to have lot of consequences, particularly on the health of the body. If we talk about the physiological conditions, it is going to disturb the thermal regulation of the body. It is going to increase, most importantly, the core temperature of the body, which we are not very much concerned about, because we always tend to go for the skin temperature. So see, skin temperature is what we look for. But in addition to that, the core temperature is an important component of the total system. So along with it, the heart rate, the sweating also increases. At times there are locations, there are people who do not even get sweating. So in those conditions, the dehydration increases, and ultimately it leads to the reduced efficiency at work. The discomfort also increases, the fatigue, the injuries, and even death in certain circumstances when the temperature reaches beyond a certain limit. So we will discuss in detail one by one. So who are practically at risk? So the people who work in the indoor workplaces as well as in the outdoor workplaces, both are at risk. It is not only the situation that if you are working under a shade, you may not be at risk. If you see the image at the bottom left, you can see these are iron bars which are taken out of the molds. So the temperature of these iron bars are around 700 degrees Celsius, which is transfused to these people who are working at around 60 to 65 degrees Celsius. And you can imagine that we get a lot of discomfort when the temperature rises around 40 degrees Celsius and people work here around 70 or 60 degrees Celsius. So what would be the condition? So this is a shaded area, but the temperature is very much higher in these conditions. So in these conditions, the difficulties to check out the difficulties, it is about, we want to look into the high air temperature, that is the ambient temperature of the air, the radiant heat sources, about the humidity that is prevailing in the work surface. Along with that, the direct contact with the hot objects, in addition to the strenuous physical activities they continue. So all these factors cumulatively is going to influence the health of the workers present in these circumstances. So these are common things in both the places, that is the indoor workplace as well as the outdoor workplace. So talking about NIOH, so NIOH has been working in this aspect of heat stress research for long. I mean, around it's about 3 decades that we have been working tremendously on this research on heat stress. So we have been working in agriculture, stone quarries, textiles, ceramics, glass industries, fish processing industry, handicrafts, in shift workers, among the shift workers in hot environment, because you can understand that industrial operation does not work in one particular shift. It can work even in a continued 3 shifts all through the day. So the shift workers is an important factor to us, particularly for the research in hot environment. In addition to that, we have also the only instrument that is available with us, that is the climatic chamber. So we also carry out the simulated laboratory studies on the hot environment. Particularly we're talking about the hot environment because it is the Indian climate is the more of a tropical climate. So in this tropical climate, the heat is more prevalent than that of the cold, except in few parts of the country. So that's why we look more seriously about the simulated laboratory activities on the extreme hot environment. So this has also given us some achievements to say, definitely, which is extreme heat related health impact. We have found out. We have also got some of the thermal limits of workers at work, because this we practically do not cannot resume like what happens in the Western countries or the other except the Indian subcontinent. So as well as we also have the temperature profiling, so as to get the heat stress vulnerability, as well as the convergence of deep body temperature, that is the core temperature, and the surface temperature, to see or understand the heat tolerance among the exposed populations. So these are some of the areas that we have worked into. I'll show you some of the images that we recently worked upon. This is the ceramic industries as well as the iron industries. We worked a few years back, and we could find several work aspects which we called as stressors among the population, among the working population who have been working. And in addition, as you can see on the image on the top left, you can find that there are 5 factors into that round, which is the psychosocial aspect, environmental aspect, technical aspect, the mechanistic aspect, as well as the biological aspect. But in these conditions, if we consider that the environmental aspect would be the largest, it is actually not. The psychosocial aspect is more importantly found as a stressor than that of the other factors. The main reason behind it is that people had got themselves accustomed. I would not use the particular word acclimatization here, had got themselves more accustomed to the environmental aspects, and that is not a big factor to them as what they say while at work. So including all these several work stressors, there are several health aspects that we have found out. We have several publications into it, and they are available, and the details can be found out there also. So recently what we are working at this present moment is on the ship recycling industries. This is the largest in the entire world. The largest ship recycling industry in the world is Alang Shipyard. So we are working on those workers, as you can see some of the images here. So this study is in progress, where we are looking into several other factors also, like audiometry, the noise factor, the heat factor, as well as the ergonomics, different ergonomics factors into these workers. So we were going to study this, and we have already started the study, and we'll come out with some results that we are focusing into. So as I said that we have these climatic chambers. We have done some simulated experiments into this worker situation, where the temperature, the humidity, the air velocity could be maintained. And what we have found, and one of the most important factor that we have found, is that the core temperature and the skin temperature of the body. The core temperature of the body is always little higher than that of the skin temperature. So when this convergence comes into action, so that is the most vulnerable status. So in this vulnerable status only, there is a chance of getting heat stress, and these heat stress could lead to several diseases, illnesses which can crop up, which can even lead to death at times. So therefore this convergence has to be somehow stopped before it converges from this core temperature and the shell temperature converges together. So that is the time where the risk starts to develop. So we try to stop it just before, somewhere just before that, by giving some other alternatives to the workers as the ergonomic steps. So what we could find in our studies earlier that we have done is the acceptable temperature would be around 38 degrees Celsius, where we can work for some a long time, around 90 minutes. Whereas the tolerable temperature at this point of time, where we can consider around 40 to 30 to 45 minutes of work, would be around 39 degrees Celsius. But this is all are, as I said, that these are all documents or results what we have got on paper, but practically if we see the workplaces, this practically doesn't work, or people do not even follow these conditions at work. So in those circumstances, physically looking into these workplaces which are really very difficult to work, so we need to find out some other alternative beyond this, because this is science and this science is required at times, and we should definitely go for science. But when we go for the real workplaces, real world, so it becomes really difficult to correlate with the data or the analyzed results that we find in our scientific endeavors. So this is what we basically see at workplaces, the impact of heat stress on occupational health risk and the productivity. If you look into the top graph, what we said here is that when the WBGT, that is the index of heat stress, wet bulb globe thermometer temperature. So when this index increases, the worker does not reduce the physical input. So in both the conditions, that means the WBGT increased, that means the heat index has increased, and the worker did not reduce the physical input. So in that circumstance, the productivity decreases. Therefore, when the productivity decreases, it means that there is a continuous physical labor which is a resultant to this serious health risk. But the problem here is that if we consider in the context of an entrepreneur or an industrial management, it is very difficult to digest that you cannot decrease your productivity. So therefore, you continue your work even if the WBGT is increased. Whereas in the other ideal conditions, or the lower graph, if the WBGT increases and the worker reduces the physical labor, so what happens as per the OH standards? The productivity decreases, but along with it, the substantial decrease in the health risk is also there. So that means this is better for their health conditions. Now this, in other terms, as I said about the industrial management part, they would say that your preventive action has lead to lower productivity. So you cannot do that. So that means a particular amount of work is defined for a total day under any circumstances, whether it is summer or winter. If I talk about the people in the agricultural aspect, so it is difficult to say that no, see, this is hot summer and I cannot contribute or I cannot produce the same amount of work. Or suppose if I am talking about, just for an example, cutting the grains or the plantation. So in that condition, if I say that you must complete a one hectare, for example, for an entire day, it is not similar in the summer than what it is in the winter season. But in those circumstances, the management part will not be allowing you to complete this in such a condition. So in both the cases, so either you continue your work and you are in physical risk of health, different disorders of your health, or else if you do the physical prevention of your workers' health, so there is a lowering of your productivity. So we need to find out some alternative steps in between, so that the management does not get prompted to take actions of less work, as well as the workers' health is also somewhat restored for their long run. So this is the basic aspect by which we work in occupational health. So what we could see is that in general, the comfortable temperature is around 20 degrees Celsius. So there is no problem into this in this temperature. So this is, you can get the maximum efficiency. But when the temperatures start increasing after all, in the next stage, so you get some mental problems. That means the psychological problems you could see. What we have listed here also about the increased irritability, loss of concentration, or loss of your efficiency. So they are more of a psychological problems that you could face. But if the temperature increases at workplace by more, this is what we are talking about, the ambient temperature. So it could lead to the psychological or psychophysiological problems, that is increased errors at work. So it can increase, there are different type of errors, so it can increase the different type of errors at work. It could be loss of your expertise in the skilled task. It can increase the accidents, which is a resultant of different numbers of errors into your work system. So all these factors can increase and can lead to the physiological problems at work. But the problem starts creeping from here when the temperature increases a little more, around 38 or 39 degrees Celsius. So there is loss of performance. There could be loss or disturbed the balance of electrolytes in your body. There could be heavy stress on the heart and the circulatory system of your body. It could be intense fatigue as well as exhaustion. So those are the start of the physiological problems into your body. So in those circumstances only we need to get proactive and take some steps so that these problems are not aggravated and converted into heat illness, which starts around 40 to 41 degrees Celsius. So in those circumstances, and starting from 41 degrees Celsius and higher, the ambient temperature at your workplace could result into different heat illnesses on you. So we'll talk about these heat illnesses, what we are talking about individually. So basically, in general, before coming into that, what we could see that heat exhaustion is what we feel at workplaces, or at when the temperature gets higher, about 40 degrees Celsius. So even while walking through the streets, we get exhaustion. So exhaustion practically is little abstract feeling that people have. Like it could have some headache, it could have fatigue, it could have weakness, moist skin, it could lower down your blood pressure or increase your pulse. So it could be anxiety. So it's an abstract type of feeling at that point of time with this increasing of your temperature. So heat exhaustion that we feel. But practically now, if we categorize these problems individually, when it starts creeping, the temperature starts creeping around 40 degrees Celsius, is these are the factors. Like rash, we could see this rash, physically visible rash on our body, which is related to the heat. The second could be the cramps on your body. It could be your fainting of your body. And finally, a situation may come when the temperature of your body increases so much that the core and the shell temperature, the surface temperature of your body are similar, and the heat cannot be dissipated by the body to the environment. So in that case, what you can see on the last image on the right bottom image. So this could happen. Now, practically, if we like to find out the definition wise, what are the problems, that we can see it here. So initially, it could be heat rash, which is another terminology to the prickly heat, and it could again result to some fatigue, which you may feel it psychologically, a little bit of fatigue for your entire body. It could result in heat cramps, which is practical paining of your body or cramp of some part of your muscles, particularly the skeletal muscles of your body. And initially it starts more frequently with the gastrocnemius muscle, that is the calf muscles. It starts with that, and it can continue to different other muscles of your body also. It, if it still continues and people are not aware of it, it could relate to heat collapse also, that is the fainting of your body because of the extreme amount of peripheral blood accumulation of your body, just to relieve the heat from the body to the outside surface. But since the temperature outside is higher, so it will not be able to allow the temperature of inside the body to come out of your body. So there it may relate to heat collapse. And finally, the temperature when there is no amount of heat of your body is dissipated out of your system, it could even lead to heat stroke, which we generally assume to be at 41.1 degrees Celsius. So these are the different effects of the heat stress on the human health. So in these conditions, to see about the factors or the situations which could relate to heat stress, we have different heat stress indices. So these heat stress indices allows us to understand whether the conditions are suitable for us to work healthy in a more healthy or conducive conditions, so that we can work for long. Because it is very difficult to say that you work for 2 hours and take 2 hours of rest or 1 hour of rest. So at workplaces it practically does not really work. So in those conditions people work for 8 hours, 10 hours, or even 15, 16 hours also. We have gone through several industrial occupations, because we work in occupational health space particularly, and completely in occupational health settings. So we have visited several industries where they work for even 15, 16 hours. So in those conditions, it becomes very difficult for them to stop their work, even either for the sake of working, that is for the productivity, or even for the sake of earning a little bit of extra income to that. So in both the conditions, this heat stress is a tremendous factor, and it's a continued factor. It cannot be considered as a factor which is a short term problem. It is a long term problem. So in those conditions, these heat stress indices are of help. So there are various indices as mentioned here, which can be calculated very easily using today's softwares in on the internet. You can Google it out, you can find it out. Heat stress index, sweat rate, CET index, P4SR is mainly used by the people in the armed forces. That is predicted 4-hour sweat rate, which is also very useful for the tropical conditions like India. Heart rate predictions. The most common is WBGT index, the wet bulb globe temperature index, and finally in 2016 onwards, there is a new index which has come up, that is Universal Thermal Comfort Index. But people are not much interested towards this UTCI and more focused to WBGT. The reason being, WBGT has a conditions where we can find out the index or the heat stress index in the indoor conditions as well as the outdoor conditions. Whereas for the thermal comfort index, universal one, so that is more concentrated about the outdoor conditions. So in this condition, the WBGT index is more preferable by researchers all around the globe. So this is how it is calculated. The WBGT indoor is the 0.7 wet bulb temperature plus 0.3 into the globe thermometer index temperature. Whereas for the conditions with the solar load, that is the outdoor conditions, particularly if we're talking about the agricultural conditions, it has one additional factor into it, that is the ambient temperature or the dry bulb temperature, which is available in nowadays in one single instrument only. We'll also talk about it because that is also a part of the of this lecture. So we'll go through it, and we can find out the load, that means the WBGT index, which is a heat stress index. Now with taking this heat stress index, it is again difficult to interpret it. The problem is not only in finding out the index. Now to interpret this index with the conditions that prevail in the particular workplace. So we have been using such situations where we have particular regiments, different regimen, and we try to see it along with the heat load that we have generated. This is a little older one, 1992 ACGIH, that is the American Council for Governmental Industrial Hygienists. So they have given. So what they said is for their conditions, and this can be modified according to the Indian conditions, and accordingly the workplace habits can be given to the workers, which they can follow. The regimen can be followed, and for the Indian conditions. So this is how it is practically done at workplaces. These calculations are being carried out. So now another most important thing that we all can follow, or we have interest towards, this is this NOAA scale. So NOAA is National Oceanic and Atmospheric Administration. So they have also this heat stress index, which they have given in Fahrenheit, and they practically use this relative humidity along with the temperature. So these two practical factors. So this is more suitable in the conditions like tropical climate, where the humidity is an important factor into the system, particularly if we consider the coastal belts of both the sides of Indian subcontinent, which is covered by seas and ocean altogether. So there, this relative humidity and temperature both combined together give the heat index, which is again useful. So this has already been used in several research. In last Kegelstrom et al., they have mentioned in 2009 they calculated it this NOAA scale, using the NOAA scale for the Indian conditions. So as if I come now directly into the factors or the instrumentations which are being used, if you can see on the left hand side, these are very two common things: the globe thermometer and the psychrometer, sling psychrometer. So these are used for the wet bulb as well as the dry bulb, and the upper one is used for the globe temperature, that is the radiant temperature on the at the workplace. So after that, there has been addition on this area of research, where we have got these micro thermal climate monitoring systems, that those are available. We have one, both of us, both of these two instruments are very handy and can be used at workplaces, and we have been using it at several research of ours, where these type of instruments can collect data, store data for long duration, and can be retrieved on the computer, so that you can do your analysis for understanding the heat load with the passage of time along with the day. So these are for the environmental climate. Yes, definitely now it is very important to understand how this environmental climate is going to affect the body temperature, that means the human or the workers, those are at the workplaces. So for this, these are again very common, as you can see. And nowadays, because of this COVID-19 problem all through the globe, this non-contact thermometer has also come up very commonly, and people have been using at every workplace about these non-contact thermometers. So they are giving the temperature without touching them. So like this, there we also have a more sophisticated system like infrared thermal imaging systems, which can also be used to find out the temperature of the skin, because it is very difficult to find out directly the core temperature of the body. So therefore the surface temperature of the body is calculated, and this surface temperature, from this surface temperature we can calculate the core temperature of your body using several equations. So this is how basically we can do it. The more sophisticated, I would like to speak about more of this sophisticated one, the infrared thermal imaging system. You can see here how it is being done. So the people are trying to find out the skin temperature of the hands or different locations of your body. So these images are live images. So we take these images and we can take it to our software system, where we can find out we can do the temperature profiling of the body. Because at times, because as we are in occupational health, we also deal with several instruments or several product design also. So in those conditions, if we want to understand that which part of your body is getting more of a heat because of your work status, so therefore we do such type of skin temperature profiling. So this is the profiling with what of the work which we have carried out at Udaipur in the agricultural field. So we are doing the profiling of the different parts of the body using the FLIR thermal profiling system. So we measured this temperature at different parts of the body and try to see which part of the body is getting more exposed to environmental heat or at the workplace, and how we can modify those conditions a little better, or we can design a product for these people for those particular areas, so that these areas are not getting affected while the workers are working in the long run. So basically, this is how we find out the profile of the body, how the temperature is affecting the individual at workplace. So why we all do these problems? Because practically before going into the last step of having heat stroke or a heat collapse, it is more prominently the musculoskeletal disorder. So this musculoskeletal disorder is not only a particular factor which is related to different force or your awkward posture or repetition of your work or long duration even work. So that means it is not only about the load bearing capacity only. So it has several other factors, cumulative factors, which really creates the musculoskeletal disorders at workplace. So which we all called it as work related musculoskeletal disorders. So these are several other factors. So now, because we are talking about the in this lecture about the environmental extremes, particularly related to heat, so we are talking about the heat as a component into it, but not necessarily that heat is only one single factor. So as I said earlier, so these are cumulative factors. So these several factors relate to musculoskeletal disorders, which is very difficult to identify or confirm that whether this condition of musculoskeletal disorders in your body or the discomfort in your body or the pain feeling of your body, which may be localized or non-localized pain in your body, is because of the work, the conditions related to your work, or it is a general concept of your lifestyle changes. So therefore, to find out these factors, we need to find out, we need to excavate it in silos practically. So therefore we do it the heat factor in relation to the musculoskeletal disorders in the body. So now directly coming into the mitigation strategy, the strategy that we can apply upon the conditions at workplace, it could be the two separate factors running parallelly. One is the environmental factor, the other one is the health factor. That means the factor where we measure the temperature or the different environmental context in relation to the environment prevailing at your workplace. The other one is the health factor where we measure, as I said earlier, about the temperature monitoring of your body. So in those circumstances, there are two practical part of it. One is the objective measurement, the other one is the subjective measurement. But in the environmental context, directly we do not have any subjective assessment. So we need to go for the objective measurement of the environmental climate. Now, when we come into the health monitoring, we need to find out both the two things, that is the objective measurement and the subjective assessment. So as I said earlier about the objective measurements, in case of the environment would be the environment microclimate monitoring, which would definitely look into the ambient temperature, humidity, velocity of air, dew point, the WBGT indices that we have spoken about. In addition to that, when we come into the worker concept or the worker part of it, so it is now related to the objective measurement is the heat illness, about the human strength that he can generate, the electromyography, that is the particular muscular electrical activity of the muscle to understand the load or the, you can say, the factors that is deteriorating the activity of the muscle, the sweat loss, the thermal profile of the entire body. So that is the objective measurement of it. And in the subjective measurement, which is equally important, although there are some studies which says that the subjective information that we get from the workers are not of importance, but yes, there are several other studies also which say that it is very important to get the subjective assessment to see the perception of the conditions, because at times in different workplaces, not all workers, not all employees would feel the same problem of the concept of the heat at their workplace. Somebody may feel it is the condition is within control, that means is acceptable, somebody would say it is optimal, somebody would say it is tolerable. So in all these three conditions, the perception of the people at work is of importance. So in addition, there is important to look into the work stressors that can create stress at workplace. So in these conditions, when we get this objective as well as the subjective assessment at workplace, we can combine this together into the using the statistical principles to find out the health hazards due to heat at workplace. Now, when you get these health hazards, practical health hazards due to the heat at workplace, it is helpful to understand and find out the long-term structured plan, which is very important. So now, as I said that I have been involved in this Prime Minister Council on Climate Change. So there we have to develop the national heat action plan for different states of the country. So every state have their own way of working. Every state have their own environmental context, have their own different work style at work at different workplaces. So in those conditions, it is important to develop the heat health action plans, which includes not only includes the health component, but it also includes the early warning, public communication. It involves the responses to the cooling centers of the high risk population of what would happen. So all these factors about, it is also important about the clothings as well as the ventilations. So these public education as well as systems to be generated in the heat action plans, which can help together to continue the working at their workplace in a more conducive way, so that they can work for a longer duration without creating much more health hazards to their to themselves. So now, continuing the same thing a little ahead is about what we practically do or practically assist the states to continue to prepare, is that human body temperature profiling. It is also important to look into the sweat loss profile, the health assessment as a whole, that is the medical assessment as a whole, the musculoskeletal discomforts, the human strength profiling, as well as the self-reported perception of the thermal health issues. So all this together lead us to find out develop a long-term structured plan for the states, which can be used by different agencies who are looking into these factors at the state level, and can be used in case of the emergencies like high heat situations in the summer months in this country, in different district, in different states of the country. So in the engineering controls, what we generally say to do is to practically dilute the hot air with the cooler air. So this is the basic thing that we generally ask the industries, because several industries come to us for finding out a protocol for themselves, how they can manage the heat as a stress factor at their work, and they can continue their work for longer duration. So what we basically do is into looking into several the factors within the industry, their work style, their work output, their conditions of work, as well as the number of workers at their workplace, their age, their dress codes, their requirement of their dress codes according to the situation what they are manufacturing, as well as looking into the gender issues. Also, we suggest some engineering controls which are here listed as in general, like general ventilation, which is diluting hot air with the cooler air, the air treatment or the air cooling like air conditioning, which is very common, chillers, localized air cooling. Somewhere we give this local air cooling also. In addition to this, there is increasing of the airflow using fans, so that the temperature can be taken out of that workplace and dissipated in the environment. We have louvers fixed up on the ceilings, so that they can continue catching up the heat that is generated within that workplaces. We have heat conduction methods where we also design the insulating the hot surfaces that are generating excess amount of heat at the workplaces. And in addition, the most important factor that is really changing the entire lifestyle is the heat island effect. So we also develop these cooler pavements or drip irrigation, greenery preservation. So like that, I'll come sometime in the end of this presentation about the Ahmedabad heat action plan also, which is very common and very well taken all over the country. So that heat action plan has also taken into this heat island effect, because everywhere this is the surface is getting concretized. So this concretization is really is actually not allowing the heat to get into the surface. So it is dissipating the heat, that is reflecting the heat that is coming to the surface from the sun. So when this heat is not being allowed to dissipate, so this heat remains as a hot bubble into this environment where we are working or we are staying or we are continuing your work. So that is an important factor. So this mitigation of this heat island effect is an important factor into our entire system. So we look forward into that aspect also. In the work practice aspect, how the workers can be given a little bit of leverage at workplace so that they can continue their work not only in tandem without understanding what they are doing, nor giving them the leverage to do their activity as little as per as their own particular schedule, not fixing a particular way of doing the work that can be given, like permit the worker to adopt healthy and safe postures at work, it is selecting the appropriate muscle groups available for that particular work. This is what we are talking about, the laborers at work, maybe in agriculture or industrial circumstances. Thirdly, performing the activities at the midpoint of the ROM, that is the range of motion. So this needs a little bit of training to the workers, which they can perform and they can well understand that how the work would really help them at workplaces. So reduced physical demands at work using shifts, intermittent rest periods, water breaks, relief workers, worker pacing. That means the way by which workers can be scheduled at work. So we design the workplace schedule for these industries and give it to them for practical approach. What we are talking here is about the practical approaches to be admitted at the industrial level so that they can continue their work in those tough environmental conditions. Limiting the working occupancy in confined as well as enclosed spaces. There are several occupations where these spaces are really very confined and very enclosed. In those conditions, if it is not also a tremendous amount of heat being generated there, it is definitely a tremendous amount of humidity that really disturbs these workers. So in those conditions, we need to look into the confined spaces. I just give you few examples, like people who are the carpenters as well as the electricians who work on the top panel of your ceilings. So they are working in confined or enclosed spaces. It is the ship recycling workers where they work in closed and confined spaces, and for these particular workers it needs to be defined, it needs to be given a particular protocol which can be used by them so that they can continue their work for long as well as also get some rest in between for getting themselves rejuvenated. So in addition to that, the monitoring of the heart rate, pulse rate, recovery heart rate, oral temperature, body water loss needs to be monitored, which is a safe as well as good work practices at workplaces so that they continue their work. In the administrative controls, definitely this is for the workers as well as the administrative front. But here there are some points which is particularly for the administrative controls, that is the management part of it. The management must have trainings which has to be dissipated or disseminated to the workers, right? Like the hazards of heat stress, because it's very common to say that now if we go to some industry or workers, if you ask a person who is working at your field, that means the agricultural workers, how is your life, how do you feel this heat stress is going to affect you, I would 100% say that most of these workers would say that it is not a problem, it is okay for us. So that means they either have got themselves accustomed to it, or they have got themselves acclimatized to it, or they feel that the importance of earning money is more important that of the heat stress. So in all these factors, it is very important that they have to be not oriented. I would rather say that they needs to be reoriented in a very short durations, like what is the problems that could happen to them in the long run due to this heat stress that is affecting them. In addition to this, the danger signs and symptoms needs to be given severely, so that people recognize that these dangers are prevailing at their workplaces. So what we have got in the Ahmedabad city also, so the Ahmedabad heat action plan, which also gives us this predisposing factors that see is these warning signs are there, so which will show you that tomorrow is the temperature is going to be so high that you need to take care of yourself, else there could be a physiological disorder to your body. So that also helps a lot. Awareness about the first aid procedures in case of such situations, employees responsibilities has to be fixed, which needs to be taken care, so that the heat stress can be managed a little. Avoiding or the dangers of using different type of abusives at workplaces or substances at workplaces needs to be controlled. Protective clothing, yes, definitely at conditions, their protective clothings are also a hazard to themselves at work. So in that circumstances, the work rest schedule has to be specifically designed for those particular workers, so that they are adaptive with these protective clothing on at their workplace. So in addition, the purpose and coverage of these environmental and medical surveillance programs has to be done, because it's very common to have somebody heat cramp or heat illness, heat related several other illnesses to be at workplaces. So what are the medical surveillance that can be extended to these workers and can help it to rejuvenate for themselves to come back to normalcy. In addition, the job organization, yes, the hot jobs should be scheduled in the cooler part of the day. That has to be redesigned accordingly, and the research would definitely find out a particular work schedule which is specific to every industry and can be easily designed. In addition, the designated ventilated recovery areas has to be fixed out. So that means what I'm trying to say in this lecture is that the researcher, like these occupational health researchers who also deal with the ergonomic factor into it, can design a particular workplace schedule for the entire industry for the benefit of both the parties, that is the administrative front, that is the management front, as well as the worker front, just to safe keep the conditions of these workers in the long run, as well as also keeping the productivity on in tandem. So this is about the personal cooling garment that has been developed by this institute quite a long back, and we have undergone several testings at different workplaces, and now it is being promoted for marketing by some industry, and we have already given these technology to some industry, and now the process is on for marketing this product into the workplace, into the industrial conditions. So this is a microclimate auxiliary cooling system. It's like a jacket which has tubes into it, which is fitted on the upper part of the body, that is the torso. Why torso? Because this is the most or the largest part of your body, which is undivided part of your body. So wearing this, the maximum part of your body can be alleviated from the stress that can be generated by the heat. So it works in a very simple principle. It has PVC tubings into it, and it runs through the entire structure that you can see in this image also. So it has inlet and outlet connectors for the transfusion of the water. So we have a small package of water backpack which can be hold at the back of the body, and it can contain around 2 liters of water along with a few hundred grams of ice, and then lithium chargeable battery is there, which pumps in the water from the bucket that is at the back, at the backpack, and then it circulates from one end to the other end, keeping the temperature of the body cool. So this temperature cooling, it can be continued for around 2 to 2.5 hours with one filling of ice and water pack, and then can be refilled. So there are other systems available all around the globe which use several other type of cooling materials In Indian conditions, what we could thought about that water is a very commonly available thing, and ice is also nowadays very readily available. So under these conditions, the keeping a weight of around 3 to 5 kgs would not be very difficult for the workers and continuing this work in the field. We have tested this jacket at different critical workplaces. As you can see here, these are all critical workplaces. In addition to I just missed out putting the images of the agricultural field, what we had studied last year at Udaipur. So we have done it at different difficult workplaces on different type of individuals at workplaces. We have also used the gender part into it, that females have also been included in this study, and we have tried to find out the temperature droppings into the after wearing these systems for around 2 to 2.5 hours of one go. So this is a DC motor, and it gives the power for the water to be circulated all through the body. So we have gone through these images of thermal imaging to find out, yes, what is the temperature drop. The temperature dropped from the original temperature, or the without the vest temperature, is around 15 degrees Celsius. That is 15 degree lesser temperature is there in the body, and this helps a lot for the workers, because it is a tough condition at workplaces, particularly either in the open field like agriculture, or in the closed context like ceramic or these iron industries, where it is really a difficult workplace. So there, reducing the temperature by around 15 degrees Celsius is a good effort. And this effort, once it is done, the workers, we have also taken the feedback of the workers, that is the subjective assessment of these workers, where the workers have also got it in a good prospect, and therefore we have now submitted it to for commercialization of this product, and now it is under process. So this is basically by which we have contributed to the occupational health system in the country. In addition, we also have gone through several conditions, like as you are seeing in this context, the ship recycling industry. It's again a tremendous physical type of work there at these workplaces. So in these conditions also, as well as sea, it is definitely ship means it is at the sea coast. So there the humidity factor is an added problem into the entire system of these workers. So these workers, how they perform their work, they needs to be reoriented, as I said several times. So how these people are getting reoriented about using these at work, at the worker level. So we go and train these workers and continue to observe them. So how they are working, how they are functioning, and how it is going to affect these workers in the positive way. So we have gone through the research study, where we had seen that yes, the factors like training, continued training and reorienting these workers has, yes, definitely increased the productivity of these workers in the long run. So this is how these workers are being explained what to do and what not to do, and which areas of your body are going to be affected in the long run if you are continuing that heat is as an important factor at stress. So therefore, because the workers, it is very difficult to make them understand in a more literary way, like what we are discussing at this present moment. So we give them this type of images to see, and to keep them these images at their workplaces. So when these images are very are near to them, so they understand, they recognize the problem which can be with this heat as an important factor in their work life, and what to do and in these conditions. So this is how the training to the workers are given at workplaces. Now, an important factor, I think I'm at the fag end of this system. So here we have also been doing this BOOHS, that is the Basic Occupational Health Services. So we have started this program from 2014, and this is still continued. This is under the WHO collaborating center system, and we are working on this system where we are trying to understand that how this occupational health, the basic occupational health services can be extended to all workers of the country through the primary healthcare system. There is a PHC system which is prevalent in the entire country. So within this, using this system that is already available with us, the primary healthcare system, the PHCs. So how this BOHs, that is the minimum factors into the occupational health care, to the can be made available to all workers. That means, so yes, we understand that this PHC is already available and they're looking, catering several people all over the country at the local level. But it is important to also understand that how this, the occupational health issues can be, or can also be catered. So we are looking into this system. We have already done a lot of surveys all over the different parts of the country, and we are going to extend it a little further to now to implement this BOHS in through this primary healthcare system. So I think this is the last slide where we are trying to say about this Ahmedabad Heat Action Plan, which is a developed plan by this the Ahmedabad Municipal Corporation and few other organizations, including the IIPH, that is the Indian Institute of Public Health, Gandhinagar. So they have given this plan for the conditions that generate, because you can understand that this Gujarat is more in the western part, where the temperature rises very high in the hot summer region. So when this, during this hot summer season, uh, there are situations where we get lot of heat illnesses, the several morbidities and few mortalities also. In those situations, it is important that advisories must be given to the people, so that they can have some protocol being maintained with them. They can take some steps also, which can help them to reduce the problems because of this extreme heat at their workplace, as well as in the general lifestyle. So the early warning systems is important, and which agencies can cater in case these conditions prevail and continue to workers, which hospital, labor department, water department, electricity department, transport department, religious activities, schools, parks, zoos, and whatever. So everything is correlated into the system, and it calls for alert or the early warning system, that what could be the condition in next day or next week. So in these conditions, we help the general public as well as the working population, so as to alleviate themselves from the extremes of this heat at workplace and in general life. So there are several publications as listed here. I have already given in my lecture note also. So these are the published papers from this institute on the occupational health and heat as a whole for the workers. And starting from 1996 to 2018, we have different work being carrying out in this area of research. So with this, I think we have come to the end of the theoretical session. Yes, definitely, as I think Madam discussed with about also showing the instrumentations also. So what I would like to ask Madam, whether we can go for the demonstration also.
Dr. Majumdar, I think we are running short of time. We are running behind the schedule.
Okay.
So we leave it for in sometime in future.
Yeah, definitely, Madam. Yes,
Uh,
thank you very
there
much.
is one question for you, Dr. Majumdar. Dr. Sawan Singh Meena is asking you, Dr. Majumdar, sir, what we recorded during some of the study on effect of WBGT on human physiology, it was observed that skin temperature reduced with increase in WBGT, that is 27 to 32 degrees. Uh, what exactly it कहाँ गया?
What exactly is it indicates?
what exactly it indicates. Is it the impact of evaporative cooling? Second is for comfort zone, what should be the maximum difference between core temperature and skin temperature? The question is in your chat box.
Just I'd like to see that what it is written in the chat box.
Is the let's check it. It is by Dr. Samal Singh at 12:31.
Okay, madam. Actually, I could not find that, but yes,
Shall I read it again?
yes. That would be better.
Uh, he says that what we recorded during some of the study on effect of WBGT on human physiology, it was observed that skin temperature
Reduced.
कहाँ गया?
Reduced with increase.
Reduced with increase in WBGT.
Skin temperature reduced.
With the increase in WBGT. So he says what exactly it indicates. Is it the impact of evaporative cooling? Second is second question he's asking is for comfort zone, what should be the maximum difference between core temperature and skin temperature?
Okay, now I got it. Now I would like to understand that what is the workplace, which work you are talking about, whether it is an indoor one or
Oh
outdoor.
no, he was working in agriculture. He's from our university, so I know.
Okay. So you are talking about the agricultural conditions.
Yes.
So basically, in agricultural conditions, you definitely have a positive factor of evaporative cooling. So that is an important factor into it. In addition, the air velocity is also important there. So if the air velocity is higher, so there is a chance of more evaporative cooling, which would definitely reduce the temperature of your skin, because it is going to be affecting more. Now it is again important to understand which part of the skin you have got the lower temperature than that of WBGT. So if it is the exposed part, that means which does not have a covering of your dress, so it is very obvious to understand. But if it is a part which is closed, I mean, if you are wearing a dress or a shirt, and if you could find the same thing beneath that dress, yes, that is a matter of definitely a matter of concern. But if it is in general skin, yes, it is because of the evaporative cooling that is increased. Now there were the second part of it. I'll again come to you if you're not satisfied with the answer. But the second part, let me answer that what should be the difference between the core temperature and the surface temperature of your body. So have you ever measured that core temperature also from the surface temperature? So that is an important factor. But in general, around 2 to 2.5 degrees Celsius difference is always there. So it is around 2 to 2.5 degrees Celsius difference is always there. But then again, you need to find out, because as I said that some part of the body would definitely be under your dress. So in that conditions, you must have to consider the entire skin surface of your body. It is not only those exposed part like your head or the hands or the feet, the temperature what you have measured there. It is also including the surface temperature which is beneath your dress. So these two factors together can totally find it out. But yes, you can find out around 2 to 2.5 degrees Celsius difference. Is it okay, or any other question is there? You can unmute yourself and can ask. No problem.
I think he's satisfied because there's no query seen in the
Okay.
chat box.
If it is there, I'd be very happy to answer you on email also. You can send me your details. We can discuss.
Yes, yes, yes.
Yes.
There's another question they are asking. Dr. Parimalan is asking, what is the cost of this cooling jacket?
Cooling jacket, madam, it is not yet marketed because we do not market it. We are only the researcher who has done the innovation. So it is going to the market. The production cost of this prototype is around rupees 3,000, but we expect it to come around 50% of it when it comes to market.
Okay, thank you. And there's one more question. During working in summer, under field condition, the major problem is sunburn on face and shoulders. Please suggest solutions that you have already done.
Suggesting solutions for sunburn would be to have covers for those part of the body, which would be again very difficult to manage. So hats, caps can be used. So that is maximally can be done at workplace, but it needs to also be seen whether it is feasible at your workplace, not hampering your productivity.
Yeah. Yeah, somebody has answered wear protective clothing. That everybody is doing, no doubt.
So it is very difficult to have
Yeah,
protective clothing in hot
yeah.
summer.
Yes, 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 yes.
You can have the
But if it is possible, the time of the work can also be changed. But in
reschedule.
agricultural, yeah, but in agricultural situations, sometimes it is not possible also.
But I think, madam, what we have seen in Udaipur also, you would agree to that, that there are,
Yes,
they distribute their work schedule in such a way that the hot part of
yes,
the day, like
yes,
2
yes.
o'clock or
Yeah,
3 o'clock, is avoided.
yeah, 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 yeah.
Yes.
Yes. Any more questions? Let me see in the chat box. Yes. Somebody is saying that Dr. Pratibha Tiwari is saying in agriculture generally May, June are no agriculture work months. Actually, the question was asked by Dr. Berwa from our own university. The earlier question that these burns are there on the shoulders, because he's an agricultural scientist, he has to work 12 months in the field. But actually, in the field conditions, the workers adjust their working times during extreme conditions. But in the
That is required. That is the situation requirement.
yes, yes, yes. So I think because there are no questions, I would like to thank such efforts to save people from the impact of climate change. Your slides were very wonderful, very nice. People are appreciating in the chat box that the presentation was very good. And thank you so much for being so supportive. Every time we look upon to you. Thank you so much, Dr. Maju.
Thank you very much to you, madam, as well as all the participants who has spared so much important time to listen to it. Yes, we are very happy to contribute anytime you require. My email ID is already there, so you can
Yes, yes.
contact us. We can
Sure.
collaborate and do some work in future. Thank you very much.
Thank you very much. Thank
Thank
you
you.
very much. मेरे को mute कर दो। Hello, participants. The next lecture in the schedule, or the rather to say the last lecture in the schedule, is by Dr. Nitin Maurya. And I have just received this message that something went wrong with his computer, and he is logged out, and so he's trying again to join us soon. And he will be speaking to us on a very interesting topic, that is design and innovation for drudgery reduction, perspectives from the grassroots. As Dr. Nitin Mora is working in National Innovation Foundation, NIF, it is called as NIF in short. So they are working with grassroots people, exploring their lifestyle, and so he will be sharing with us some of the grassroots innovations, which are going to be very interesting, I'm sure. And we are just hoping that he joins us soon. And in the meanwhile, let me introduce him to you. And I'll just go to my slide about his introduction. Just a moment, please. Nitin. Ah. Ah. So friends, Dr. Nitin Maurya holds a doctorate degree in anthropology from the University of Delhi. And he currently heads the Dissemination and Social Diffusion Department at National Innovation Foundation in India and its Northeastern Region office at Guwahati. He also advises various state government departments and institutions on innovations. He has also been a National Talent Scholar of NCRT and the recipient of Junior and Senior Research Fellowships of the Indian Council of Medical Research, ICAMR. So Dr. Nitin Maurya will be joining us very soon. So you must have all, in the 5 days, you must have all noticed that our resource persons were really very exceptional. They were very nice. Each one was like a gem in their own field, and everybody belonged to the very leading institutions of the country, and their deliberations uh, must have benefited you a lot. And I look forward that we get more queries from you regarding if you have any difficulty in your work pertaining to the area of residue reduction in designing of technologies or assessment of technologies. So and in these 5 days we got so accustomed to this schedule, you know, that today we are all the organizing team members are feeling that we are going to lose your company, because it is a human nature that if you are in contact with good people for a couple of days, it becomes your habit. So it was very nice being with you all for the 5 days, and we got good participation from you. The 100 seats were almost full. That's why we had to go on to the YouTube live streaming. So it was nice. Let me just find out from Dr. Nitin on phone that how much time it will take. Yeah, I got his message that he'll be joining us soon. And participants, in the meanwhile, Dr. Nitin catches up. I would like to introduce you to my colleague, my student, my backbone, Dr. Hemu Rathore. You have seen her very less on the screen, because she works off the screen. She is such a support to me always in this training, in all other works. So Dr. Hemu Rathore was the organizing secretary of this training program, and she has really worked hard behind the screens to make this program successful. Then we also have our we also have some of our more members on in the organizing team. Dr. Piyush Jani, are you there? Dr. Piyush Jani? Dr. Piyush Jani, are you there? I can see Dr. Gayatri Tiwari is there. Dr. Gayatri Tiwari? She was,
Hello.
Dr. Gayatri Tiwari.
Good afternoon, madam.
Yes,
Good
yes.
afternoon, madam.
I'm just introducing you to the participants.
Thank you so much, ma'am. Thank you, ma'am.
Dr. Gayatri Tiwari was also in the organizing team, and she is associate professor and head of the department of HDFS department in our college. And she's a very good orator and very good writer. And I'm just looking forward to Dr. Piyush Jani if he is there. Dr. Piyush Jani, can you hear
Good
me?
afternoon, all and all. Good afternoon.
Then we also have a very, I just wanted to tell you that our, organizing team is like a joint family. Like in a joint family, various generations live together. So we have three of us are senior citizens retired from university. Then there are mid-career people also like Dr. Gayatri Tiwari and Dr. Hemu Rathore. Then we have young professionals with us. You are meeting her every day to wrap up the show, and she is Prachi, Dr. Prachi Avinash. She's a postdoctoral fellow, and every day you are seeing her in the end of the program. She's wrapping up the day's program, so she's also working very nicely. And I wanted to introduce you to one more young boy who is looking after all the technical things of this program. But right now he has gone to see his experiment. As soon as I'm in touch with him, I'll introduce him to you. देखो आएगा सबको करो इंट्रोड्यूस करो just a second please, just a second.
आगे 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 आगे
पार्टिसिपेंट से भी तो पूछना था. Dr. Nitin, are you there? Dr. Nitin Maurya? Yes, there. Dr. Nitin Maurya, are you there?
Yes, ma'am. Can you hear me? Good afternoon.
Yes. I have already introduced you and we were waiting for you. So I think we should start the session.
Yes, ma'am. Certainly. I'm so sorry.
No problem. It happens with technology. We understand.
Dr. Majumdar was finishing his presentation. He was on the last slide. Something happened to my computer.
Yes.
So that shows that sometimes technology cannot be reliable also.
Really.
Okay. Good afternoon, everyone. I am joining you from Guwahati. And before I start, let me first admit that I'm not a subject matter specialist here, and my experiences, the presentation that I will be sharing with you, and I'll about some things that I feel are important. And this is based on my experience as an anthropologist and my work at the National Innovation Foundation for the last 15 years or so. So you have had a lot of technical presentations last few days dealing about various issues related to design, ergonomics, with different presentation. In my presentation, I will try to talk about some issues which I feel may be important. So there are no solutions or answers that I am providing my presentation. It's more about discussion and more issues. So if I have to take three key points, three keywords from the last three presentation, so those will be strain, risk, and stress. And none of these are there in my presentation, though I could eliminate drudgery from my presentation. I'll be talking something about drudgery. So I'm just sharing this. So are you able to see the presentation? So is
It is
this visible?
visible.
I hope.
Yeah, it is visible.
Okay, okay, okay. Thank you so much, John. Thank you so much. Okay. So 2 days back, while I was preparing this presentation, I encountered this broken water cooler in an institute. So which kind of intrigued me. So I thought, okay, why not I should use it in the presentation. So this is, as you see, a water cooler where the taps are slightly broken, they are down. So I started thinking what could possibly be the reason for this? Because when we are talking about drudgery, we are talking about technologies, and the technologies need to be suited for the actual users. So what I realized that this cooler was installed in a higher institution, higher education institution. Site is approximately 4.5 feet, while the people who are using it, they are 5.5 feet and taller. So when they use it at this height, this is a push type knob. You have to push it inside, so the pressure is inside. But when a taller person is using it, so what he inevitably does, he puts his weight on the tap. So by putting the weight on the trap, this particular design, as you say, this gets broken. It just slips off. So no matter how you hard you try, but the users, they are going to inevitably put down some of their weight. So was this particular cooler more suitable for somebody of lesser height or maybe in this? So that was the question I was pondering about. So this is a technology, this is a commercial technology, but where can be the fault actually lie? Is it a faulty design, wrong location of the cooler? It should have been in a school rather than it is there in a higher education institution, or the people who are using it in a wrong way. So this is open ended. I'm not needing an answer and I'm not giving an answer, but this I thought was very important. So I put it in the first slide. And as I mentioned, drudgery. So we have been talking about drudgery, different kinds of stresses, strains, and I could not just remove this drudgery from my presentation. So what I'm trying to do is give certain perspectives, thoughts about drudgery as I feel, as I have seen in last 20 years or so during my career. So when we are generally designing machines or tools, we are particularly talking about one particular maybe activity. We are talking about one particular environment like office space, agriculture, field. But what I feel that there are a lot of activities which are dependent and there are a lot of activities which are independent. Some interconnected activity, if we look at it in isolation and try to develop a tool for that, probably that is not going to reduce the drudgery. For that particular activity, yes, but maybe not for the individual as a whole. Let's see for an example. So this is something which is very common in our country. Women folk, they are carrying firewood on their head. Now, if this is considered as a drudgery prone activity, probably the first thing that we will like to do is to somehow uh, get a tool using which he can carry it, maybe pull or push or something that reduces the stress on her neck and the backbone. But if you look at another angle, maybe we can improve the design of the stove, or maybe we can give her a gas stove. What you are actually doing by improving the design of the stove is, suppose this lady walks 4 kilometers every day and carries 5 kg of firewood. If you improve the design of the stove, you by say 50%, that means the lady who had to go out in search of firewood, she will now go out only on alternative days and maybe use the same quantity, same amount of firewood for maybe 2, 3 days, 4 days. That is also one aspect when where we can say that we are actually reducing drudgery. So drudgery has to be viewed not in absolute terms for a particular task, but maybe a number of things which are interconnected or interdependent. Sometimes it so happens that due to some cultural reasons, social reasons, or maybe commercial reasons, we institutionalize drudgery in particular tasks. This is very important to consider as well. So this particular case I have taken from Kashmir. Kashmir is the largest grower of walnuts in the country. And most of those walnuts, about 98%, 99% of the walnuts, these are cracked at home by women and children using traditional tools. And if you see the equipment, this is from the Jammu Kashmir Entrepreneurship Development Institute, it says manual cracking is preferred. They prefer manual cracking because if the pressure in a machine is more, then these kernels will get spoiled. So they are kind of institutionalizing this manual drudgery, which has been going on for ages. What has been the result? There is one grassroots innovator, Mushtaq Ahmad Da, from Anantnag, Kashmir. He developed this walnut cracker. So we evaluated that cracker, engaged designers and engineers, and developed this particular walnut cracking machine. But the diffusion has not been very great to talk about. It has been rather limited and only in pockets because of the preferences of the industry for manually cracked walnuts. So this is one example where the drudgery gets inherent in the process and it gets institutionalized over a period of time. Optimality. Now, for one particular task, there may be many machines, whether mechanized or automated, both kinds available. And sometimes it also depends upon the choice of the person, choice of the user, what he actually wants. An example I'll give you. This is a multi-purpose processing machine which can process various kinds of herbs, flowers, and fruits. And one can get juices, extract, essence, and prepare different other kinds of things. So this is one design that the innovator, Mr. Dharamveer Kamboj from Yamunanagar, Haryana, he made. So this is a very suboptimal design. You can see there are a lot of instruments which are jetting out from this design, from this machine. And there are a lot of ergonomic issues also, where the user has to bend for a considerable period of time to load this machine and to clean and to take out these processed foods. So this is what we did. We engaged a designer, and this is the machine that we got made. And in it, it eliminated all the technical issues that were associated both in terms of design, ergonomics, and usage. But yet, uh, there are people who are preferring the previous design over this design because the farmers who are using it in their field, they are not much concerned about the design, look, security, and safety. They are more concerned about the cost of it. So this particular, the first version, it's about 20-25,000 rupees cheaper. So that is what I meant, that sometimes even though there are optimal solutions available, but people choose suboptimal solutions because of the cost factor or some other reason. Now this is economic economic condition. Now when we are talking about drudgery, we also need to realize that sometimes some people, they don't have choices. There may be machines available, but there may be little awareness about it. There may be awareness, but the availability of such machines may not be there. The machines may be available, but such tools and devices and machines may not be accessible. And in the last, affordability. Affordability is a very big issue in our agriculture sector, as we all know and as we all have seen. Affordability of machines with optimal design is not there. That is why a number of grassroots innovators, as we see from different parts of the country, they are continuously improving different kind of agriculture machines. So they are not very drastic improvements, but they are incremental improvements. But that incremental improvements itself show that there is a lot that desired by the actual users who are using this machine. And the last point, which I think is important, is diet and nutrition. I'll give you one personal example. So the example is that few years back, uh, I started having pain in my forearms and my wrist. So I thought probably the height of my table is little more. So I got that changed. Then I got one ergonomic chair, so-called ergonomic chair, purchased for work. But then the problem continued. So I got myself tested and that vitamin because of which these all kinds of pains were there. So diet actually very crucial role in, in this treasury reduction. But especially if we say that if we talk about people or women folk who are engaged in agriculture, diet is also very important. But as I understand, it may not be possible for one person or a couple of researchers to research in a large variety of fields or domains. So sometimes in some contexts, maybe a consortia of researchers from different backgrounds may also be there who can research on various aspects, so that the solution that gets delivered to the people who in any case are facing drudgery in different walks of their life, so they are able to get relief. But then is there a need to eliminate all kinds of drudgery? So this is one question that is probably an antithesis to all kinds of discussion that you may be having till now and the work that you may be doing. Let us see some scenarios. Scenario one is regarding household chores. Earlier, 2, 3, 4, 5 decades back, all of our household work was using mechanical devices. Then we automated a lot of devices and new appliances and tools, etc. They got introduced in our homes, so that eliminated a lot of drudgery. But then physical workout also got reduced, and with the change in lifestyle, a lot of health issues were there, and lifestyle diseases they started getting into our lives. If you see the current corona COVID-19 situation, who are the people who are getting the worst affected? They are the people, those people who have these lifestyle diseases, who are the risk of cardiovascular diseases, hypertension, and diabetes. So from where did this originate? This originated from our dietary habits. This originated from our lifestyle. Right? There was a recent research by WHO in Southeast Asia where it shows that 40%, 44% women, they have become more inactive over a period of time, and 53% women uh, have become inactive in India, and they have attributed that these factors could be as a result of mechanized household appliances. Now, in context of agriculture, it is very important to improve the health of the agriculture worker. To improve the productivity, we need to work on various tools, devices, mechanizations, and automations where the drudgery is eliminated. Then again, the same problem is there. There are a lot of health issues which are associated. I'll give you an example from my PhD fieldwork. My PhD area was Car Nicobar in Andaman and Nicobar. So once I went there for my first fieldwork, I saw a lot of people who appeared to me were overweight and obese. So that was kind of very surprising for me to see in an isolated tribal island people who are actually obese. So in my next trip, in my next fieldwork, I included this particular study on obesity in my thesis, and I went there with all my tools and other things and measured this. So what I found out that after independence, there was a lot of focus of government of India to support people with rations. Now traditional people, they had been living with their traditional lifestyle, eating traditional foods. Suddenly the refined sugar, the pulses and the rice and everything, they started getting imported into that island. For a long period of time, their lifestyle remained same. They were using the same amount of coconut oil that was freely available there. But gradually, while their dietary habits remained same with addition of the government supplied rations, their lifestyle got changed, as a result of which the input in terms of calories that they had and the output in terms of expenditure of calories that they were undertaking, there was a lot of difference, and hence they started accumulating fat. So that was something which was very interesting. So we we need to ensure that whatever things that we are planning and proposing, it somehow takes into uh, consideration the various positive and various negative effects also, which may be possible. So in 2019, this study was there in India and Ghana, where it meant there was a longitudinal study for about 27 months, which I read recently, and where they found out that the introduction of drudgery reduction methods and tools among the rural households, primarily the agriculture sector, it resulted in incidence of obesity. So I actually did not do any such research, but then this research also corroborates my observation way back in 2002 and 3. Now let us see in some other occupations, like a cobbler or a potter or in office or some traditional schools, there were certain postures which were considered as awkward postures, and there were suggestions for posture corrections, and there were products and devices that were provided to people to start using, so that they can improve the quality of work that they are doing and their health, reduce treasury in that. But it has been well documented fact, even in our yogas, which have scriptures written hundreds of years ago, that there are certain postures which are beneficial for the body. For example, the Bandakon asana, in which the cobbler works, there has been research which proves that it helps in preventing sciatica pain and hernia. And the cross leg posture, like we said, जिसको बोलते हैं पलथी मार के बैठना, सुखासन, during a study among school children, it was found that the postural deviation was really less. So it has positive advantages over the postures that children used to take in regular normal modern schools. uh, uh, so what I mean to say in this, that while we are designing, while we are developing technologies for drudgery reduction, there may be a suitable trade-off that we may have to make. That trade-off may be for the with respect to the advantages, with respect to the disadvantages, and then maybe we can take a proper assessment and then choose how much and where exactly the intervention has to be there. For example, in 2012 and 2020, 2015, my office it announced the Gandhian Inclusive Innovation Challenge Awards. So those awards were for three challenges. The first challenge was to develop a stove. The second challenge was to develop a paddy transplanter, and the third challenge was to develop a tree leaf plucking machine. Now, when we were defining these challenges, we made sure we ensured that the drudgery portion in this particular challenges was eliminated, but entire manual work was not eliminated, because when you are working, there are some advantages of physical work also. So that is the trade-off that I was talking about, that we have to make somewhere when we are designing, developing drudgery related technologies. Now let me give you some examples. So this is a paddy variety from Tamil Nadu, which can be easily weeded. So when we talk about weeding, generally different kind of weeders and the effort in doing that, it comes to our mind. But imagine this paddy variety which has purple pigmented leaves, which get easily differentiated uh, from the weeds that grow in the soil in the field. That itself makes the weeding very easy. So this is one different angle to look at one specific problem. Now this is one tree climber again from Tamil Nadu by Mr. D.N. Venkat. This is a multi-tree climber, and along with coconut, people can use it to climb many other trees. So historically, if we see, there were a lot of activities that were being undertaken both by men and women in agriculture and otherwise. Lot of for a lot of activities there were tools and devices developed, but in most cases whenever there were mechanization, those tasks were taken up by men, and women folk were again left to do the drudgery prone tasks, which happens till today. So instead of focusing on gender specific or gender friendly technologies, I think it is time now to move towards gender neutral technologies. There should not be any difference, and both genders should be able to use it properly. As you see in this particular picture, this lady is wearing a salwar suit and is climbing a coconut tree. So this technology is an example of gender neutral technology. Now, in many cases, in our field, especially in horticulture, what we have to do, we have to protect our fruits from birds and other animals. Now, this gentleman, Mr. Saji Varghese from Kerala, he has developed a very simple fruit and vegetable capper using which you can cap a fruit with plastic, paper, or cloth, whatever is available, in less than 5 seconds. So this is a stick with a lever, and there is a cloth or a polythene which is there. You just have to cover this and then press the lever, and immediately with the help of a rubber band, it will cover the entire fruit. This is a very simple and useful technology which can be used by anyone. Pesticides are necessary evil. We need them to keep our crops safe, but 99.9% of our farmers, they never use any particular mask when they are spraying pesticides in their fields. So what these four young boys from Gujarat, what did they do? They developed a technology integrated with the sprayer, so that if the person is not wearing a face mask, he will not be able to operate the sprayer. So it is like, if you are not wearing a seat belt while driving your car, you are not able to drive, you are not able to start. From compassion to creativity, sickles have remained same for years and ages. Nobody ever thought that if a farmer who is working in the field somewhere away from his home or away from village, if he gets hurt, what he will do. So this young boy, again a school student, he said, Ki, why can't we have a small first aid kit in the handle of the sickle, so that whenever there is an injury, person has ready access to all the first aid materials. This is a very simple idea, but somehow it eluded the minds of everyone. So when we are researching on drudgery, when we are looking at the problems of people, when we are coming up with solutions to solve their problem, if we can have a more empathetic and more considerate, more compassionate approach, probably I think the results of our efforts are going to give more fruits. We have a lot of data. Every year we produce a lot of data on different parameters, but now from data we need to derive some insights and then probably take these into consideration further to work towards developing these uh, products or technologies. This is one good book that I recently read, Design for How People Think, by John Wellen. So those who are interested may purchase it and go through. So he has very nicely explained all this process which is mentioned here. So this is a very familiar, very familiar uh, graph for everyone who has joined here. Rogers 1961 diffusion of innovation. So this is essentially talking about uh, the phases in which people adapt technologies. But then, as I mentioned earlier, there are different reasons also why a person becomes an innovator, why a person is an early adapter or a laggard. So these reasons are not directly related to the risk taking ability of a person. So these reasons are beyond that. For example, somebody may be risk averse, so he may be a laggard or a late majority, but there may be conditions which are beyond the control. For example, as I mentioned, accessibility, availability, affordability, and maybe awareness, because of which people are generally inclined to whether accept a technology or not accept a technology. So just quickly mentioning about the organization that I come from, National Innovation Foundation. So we are into promotion of uh, technological innovations from the grassroots, that is people who are not formally trained or educated but have worked in the laboratories of life. So we document a lot of innovations from all over the country. So we have currently over 3,15,000 ideas, innovations, and traditional examples, and we get these validated and evaluated through our partnerships with different institutions. And we file patents. We have filed close to 1,100 patents in the country, of which 163 have been granted. And then we also support for social and commercial diffusion. We have a technological business incubator, MBIF, Nifentric, under which we incubate grassroots innovation-based technologies. So we are also working on a large number of technologies, primarily from the agriculture sector, because we work on the informal innovations, and agriculture is the largest employer for the informal sector innovators. And a lot of technologies we receive from different parts of the country. So we have a fabrication laboratory in our office headquartered at Gandhinagar. So where we undertake research on these technologies and also aspects related to ergonomic design and drudgery reduction. And we develop prototypes and products in-house. And we also have a network of 63 community workshops spread all across the country, from Kashmir to Kerala and from Gujarat to Mizoram, where we have set up such similar, not such elaborate, but similar facilities at a lower scale, so that the transition of an idea into a prototype or a product can be there. These are some glimpses. And we are also undertaking a lot of activities for social diffusion of innovations. And for that, a lot of innovations that we get from one region of the country, we try to introduce in another region. And during this process, a lot of localization is also there to suit the local conditions, to suit the needs of local culture. For example, there is one technology from Gujarat for cremation, normal Hindu cremation, where the body, in our cremation, we have body lying horizontally, but we are trying to bring it to one state in the northeast where that cremation is in a sitting posture, sukhasan. So we are trying to change that technology from that aspect to this aspect. So a lot of localization is also what we do. So this is one program, Inspire, for school students. We are also the lead partners for the National Entrepreneurship Award 2020, which got postponed. It will be there in next year. And we also partner in a lot of bilateral and multilateral international activities. And some of our innovators, they also get recognition at the national level by Padam Shri. They have got Padam Shri. On the left, you see Shri Jagdish Prasad Parekh ji from Sikar, Rajasthan. What he has developed, he developed a cauliflower variety, one bulb of which it weighs 12 kgs. On the right, we have Vallabhbhai Marwania. He developed a carrot variety, which we recognized, and later he last year, I think 2019, he was given the Padma Shri. So these are some activities. So this is in brief that I had to share. And I conclude this presentation. I'm so sorry. I literally was very nervous because just before the presentation, my computer went into sleep and I had problems waking it up. So, but I am happy that finally I could make this presentation. So I conclude with this. If there are any questions, please let me know.
Are there any questions, participants? I don't think so. Mr. Maurya, Dr. Maurya, it was a very, very nice presentation. We were looking forward to it. Last but not the least, and very good examples you had given us from the grassroots level. And your institution, NIF, is also doing wonderful work in recognizing the creativity of the people at grassroots level. I really like that idea of first aid box in the handle of the sickle. And this is also really, we have to think about it, that whether to introduce treasury reduction, how much treasury reduction should be done, as you gave the example of obesity.
Yeah.
So it's
Ma'am, actually,
especially
this is a really very vicious circle. Problem, technology, problem, again technology. We keep on going. So when we face one problem, we develop a technology. We don't realize what possible problems that technology is going to create, and then again we have problems. Then again we develop technology.
that's true. So the world must go on that way only.
But the world must go on. Whatever best we could do, we should do. Certainly.
Yeah. People are appreciating your presentation. Please
Thank you so
check
much.
in the chat box. There's so many comments in the chat box. You wanted to share something, Dr. Nitin, uh, right now, or will when we send you the list of participants?
Okay. I'll just talk about it now. See, we are actually, as I mentioned, we are into the incubation of grassroots innovation, and we are also looking for innovators from all parts of the country. We are a very small office. We are headquartered at Gandhinagar, Gujarat. We have our office in Srinagar. We have office in Dehradun. We have office in Guwahati and Bhubaneswar. And primarily, we are working through partnerships and collaborations all across the country, because that is what we feel, that instead of growing ourselves, our network should grow. We should engage more and more people, so that will keep us small and humble, and we will have a large number of partners. So uh, I invite any one of you who would be willing to join hands with us in either scouting or documentation of innovations from different areas, or maybe validation of technologies. So if anybody's, or in fact diffusion, so a lot of technologies, we have a lot of plant varieties, we have agriculture devices which are available with us in our database, which we are introducing, which we are trying to introduce through our various partners in different parts of the country. But in case uh, in your region where you work, you find any such problem related to agriculture or any other sector, kindly let me know. So what we'll do a technology problem matchmake at our end, and if in case we have a solution for that problem, we'll be very happy to facilitate the introduction in your region. So I think that is what right now I'd like to say. Thank you, ma'am, for remembering this. I
I
forgot.
opt myself for this work. We'll talk later.
Sure.
Sure. So thank you very much, Dr. Moria. It was wonderful having you with us, and your session was very fruitful for us. Thank you very much.
Thank you so much.
Please stay with us till vote of thanks.
Okay.
Friends, as I told you, that Piyush, that I'll introduce you to a young, smart boy who is a budding professional, uh, who helped us with all the technology behind this 5 days training. And as I said, we were like a joint family. All the generations were in our organizing team. So he is the youngest of all. He is Piyush Chaudhary, pursuing his PhD in agronomy in the College of Agriculture. So please meet and appreciate and applaud Piyush Chaudhary. He is on the screen. I'm so happy to introduce you to Piyush Chaudhary. He's the youngest member of our organization. Thank you, Dr. Maurya. And your appreciations are needed for him. And he's doing a wonderful research using nanotechnology in plant growth of maize, I think. You can tell them. So thank you very much. And now I invite Dr. Prachi Avinash for vote of thanks.
हाँ वो कर देंगे आपको.
Gratitude is not only the greatest of virtues, but the parent of all others. Gratitude is not only the greatest of virtues, but the parent of all others. I deem it a great honor to propose the vote of thanks to all of those who have worked in and out in making this 5 days online training program on ergonomics methodologies for designing and assessing women-friendly agriculture tools and technology such a resounding success. The first mention of Honorable Vice Chancellor, Maharana Pratap University of Agriculture and Technology, Udaipur, Dr. Narendra Singh Rathod, brings a sense of pride and enthusiasm as his visionary and able guidance orients us to take up contemporary issues. He is a true source of inspiration, and we feel immense pleasure working under his leadership. I extend a very hearty gratitude to our Dean, Dr. Meenu Srivastava, convener for the event, for infusing in us the enthusiasm to work. I have dearth of words to express thankfulness for her kind support and guidance in organizing this training. My hearty thanks to Dr. Ajay Kumar Sharma, convener, Dean CTAE MPUAT Udaipur, for providing us encouragement and support throughout. I extend my gratefulness to Dr. Seema Dwivedi, Head Department of RMCS, CCS MPUAT Udaipur, for her kind and affectionate leadership and backing. On behalf of the entire organizing committee, I must mention our deep sense of gratitude for the eminent speakers for the 5 days training, whose exemplary, distinguished, and enlightening deliberations will be brought into action. And I'm definite that each one of the participants must have learned a lot from each of the speakers, since they are the gems, as Dr. Suman ma'am has expressed, that they are the gems of our country working in the very leading institutions. I feel pleasure in naming each one of them. Dr. D. Majumdar, former scientist G, DRDO, New Delhi. Dr. Y.C. Bhatt, Professor retired, Department of FMPE, CTAE. Professor Dev Kumar Chakrabarti, DOD, IIT Guwahati. Dr. Manjeet Kaur Chauhan, Associate Professor, Department of FRM, SNDT Women's University, Mumbai. Dr. S.S. Meena, Assistant Professor, CTA, MPUAT. Dr. Sudesh Gandhi, Professor retired FRM, CCAS, Hisar Agriculture University, Hisar. Professor A.M. Runalini, former Dean, CCAS, PJSTAU, Hyderabad. Dr. S.P. Singh, Principal Scientist, IARI, New Delhi. Dr. Anirban Chaudhary, Head UEID, University of Petroleum and Energy Studies, Dehradun. Dr. Tirthankar Ghosh, Professor and Consultant Occupational Ergonomist, Faculty of Health and Wellness, Shri Shri University, Cuttack, Odisha. Dr. Joydeep Majumdar, Scientist, NIOH, ICMR, Ahmedabad. And Dr. Nitin Maurya, Scientist and Coordinator, NIF, Guwahati Cell for Northeast Region, Guwahati. It won't be appropriate if I do not acknowledge with thanks the cooperation and contribution in one way or the other of the entire organizing team, the ever-smiling Dr. Hemu Rathore, Organizing Secretary and Associate Professor, Department of RMCS, the very efficiently expert Dr. Suman Singh, Coordinator, Professor, RMCS, the idol of confidence, Dr. Vandana Kaushik, Co-Coordinator, Professor, RMCS, the person of intellect, Dr. Piyush Jani, Co-Coordinator, Professor, Agronomy, RCA, MPUAT, an expert orator, Dr. Gayatri Tiwari, Co-Coordinator, Associate Professor and Head, HDFS, and the technical support behind the 5 days organization, Mr. Piyush Chaudhary, Research Representative and PhD Scholar, MPUAT, Udaipur. I heartily congratulate and thank all the participants for their active participation in this event, without whom this event would not have been a success. I once again thank all the named or otherwise with a phrase, mind is full with sense of immense gratefulness, but words could not express properly. With these words and strong hope to meet you all again, I bid farewell, as goodbyes are not the end. They simply mean we will meet again. Thank you. Over to you, Suman ma'am.
Okay, thanks so much, Prachi. You have named everybody, so I name you. for your very nice contribution in organizing this 5-day training. Thank you very much, Prachi, for your efforts and for your contribution. Okay, participants, bye-bye. See you soon. And it was very nice having you all with us. Have a very relaxing weekend ahead and hope to see you soon. Bye-bye.
ऐड कर दो वो होस्ट है वो करेगा अच्छा तो देखना फीडबैक it will be uploaded
फीडबैक कह देते ना फीडबैक फॉर्म विल बी सेंड सून कर दूं लिखो participants, for your information, feedback form will be soon sent to you. Please complete it until we receive your feedback forms. We are sorry, certificates cannot be given. So please complete your feedback form and all this work will be done within a week's time. Thank you very much.
कर रही हूँ मैं लीव हाँ हाँ मतलब एंड करके